What's up? And we are back again with lesson 2 of part 1, and we are still going strong on differentials in calculus. So now, prepare as we dive into the questions. Alrighty. So now, starting with question 8, and this is 8.1. They say that we have to determine the derivative of our function f of x from first principles if we are given what? A function f of x which is equals to 3 multiplied by x raised to an exponent of 2 there. So guys, every time you hear from first principles, it means you have to use the long method, which is the first principle formula f prime of x, which is equals to what? The limit as he approaches to 0 of f at x plus h minus f of x and everything divided by h. And remember that he cannot be 0. Why? Because now this entire equation, it is going to be undefined. Just think of it as having 0 as your denominator there. Anything to what? Anything divided by 0 there, this is going to give you undefined. Yeah? So now he cannot be 0 there. That's why we are taking the limit as he approaches to 0. So now guys, before we make use of this first principle formula, let's first understand each parameter in this expression. So now, when we are talking about this part here, this is the derivative of your function f of x. Yeah, this is the derivative of what? Of your function f of x. And then this part here, this is the limit as he approaches to 0, meaning we are looking at what's really happening to our expression as he approaches to 0, yeah? Or as he becomes extremely smaller. So now, this part here, this is the function evaluated at x plus h. Remember, the meaning of evaluate means to substitute numbers into the formula and then evaluate your answer from there. So now, this part here, this is also known as your original function or the function evaluated at the original value of x. Meaning when you evaluate your function at the original value of x, you'll have what? F of x. And when you evaluate this function at x plus h, you'll have what? X plus h there. So now you see you have f of x, you have f at x plus h, and that's what you have as your numerator there. So now guys, let me use people. So now this what you have as your numerator there, your f at x plus h minus f of x. That's the average rate of a change over what? A small interval. Think of your numerator there as you wanting to determine the gradient on a straight line. You'll see what? This is y2 minus y1. And this is also known as what? Change in y. So you are what? You are looking at y2, between y2 and y1 there. So now that's known as what? The average rate of a change over a small interval between y2 and y1 there. I hope you understand. So now let's talk about the entire expression. The entire expression tells us we are taking the limit as he approaches to 0, or we are taking the limit of our average rate of change over the interval he approaches to 0, giving us the instantaneous rate of change, which is known as the slope, which is also known as the gradient. You can say this is also known as f prime of x. To what? To the tangent line at point x, at point x. That's why you can see that this whole thing here, your product is what? Your product is f prime of x. So this is what? The slope at point x there. That small x there. Understand? Okay. So now allow me to erase everything there. Alrighty. So guys, they say that we have to determine the derivative from first principle. So number one, your first step is to evaluate your function at the original value of what? Of x. So now this is the same as writing your original function or the given function there, which is what? 3x squared. So now the next step is to evaluate your function at x plus h. This is the same as replacing everywhere there is x with what? X plus h there. Understand? So now keep the 3 outside and evaluate your function at x plus h. Remember, I told you that the meaning of evaluate means to substitute numbers into the formula and then evaluate your answer from there. So it is the same as replacing everywhere there is x with this x plus h. So now this 2 there tells you now you have what? The squared binomial. Yeah? So it means you have to deal with that before distributing the 3 inside. So keep the 3 outside and then deal with this. You'll have x squared plus 2x he plus he squared. So now distribute the 3 inside the, you'll have what? 3x squared plus 6x he, sorry for that, and then plus what? Plus 3 he squared. So now therefore, this is what? Your f at x plus h. We have f of x, we have f at x plus h. So now it means we have what? We can make use of what? The first principle formula. Ne? We can write down the first principle formula since we have set up the mathematical model. We have f of x, we have the function evaluated at x plus h. So now your f prime of x. Why am I saying f prime of x? Because I am saying f prime of x because our function is what? Is f of x. So this is going to be what? The limit as he approaches to 0 of your function evaluated at x plus h minus your original function, which is the same as your function evaluated at the original value of x, and everything divided by h. And remember, guys, that we have this restriction that he cannot be 0 there. So we have to try by all means to eliminate he at the denominator there. Understand? So how do we do it? So now we're just going to make the substitution first. So now you keep the limit. So this is the limit as he approaches to 0. Your f at x plus he, it is just that part there. So you'll say 3x squared plus 6x he plus 3 he squared minus this negative here that you see came with the first principle formula. So now it tells you now you have to protect your original function, which is 3x squared. So always protect your original function. So this is all over each other. So you know that we don't like wasting time. So what you have to do is to distribute the negative inside your left, negative 3x squared. This tells you now the 3x squared and the negative 3x squared, they are going to rationalize. So now what you have there is what? The limit as he approaches to 0 of the remaining part, which is the 6x he plus 3 he squared. So now, if you are to check that those ones that we just cancel them, or the ones that we rationalized, you can see that all of them have what? The x squared, but none of them have what? The h there. So now this tells you now this step here, you have to have your numerator as what? As 6x and what? And h. Ne? You have to have what? 6x and h as what? As the products there, or just h there. You understand what I'm saying? The reason of this is for us after this step to what? To take out the factor, which is the h, so that we can eliminate the h at the denominator there. So what I mean is that h is common everywhere there. So h has to be common, guys. You shouldn't have something like let's say 3x squared there. Yeah? Because now how are we going to take out the factor which is h there? There is no factor now, because now you'll have to take the factor here, but what about this term here? So it means now you are not going to rationalize the what? The h at the denominator. So now after rationalizing your terms there, you have to have your x and somewhat h there. Understand? So now since h is common there, that's your factor, guys. Once something is common there. That's what your factor. So factor h out, you left 6x plus 3h, and then what? All over h. So now you see the numerator and the denominator rationalize. So now it tells us now we can take the limit as h approaches to 0. So now this is the limit as h approaches to 0. We haven't took the limit yet, but we just have to write down what we have for now. So now uh, at this stage, guys, this is the stage where you'll have to what? To make the substitution in the place of h. But remember, you don't have to show in your calculation that you are making the substitution or replacing with 0 where there is h. You have to do that mentally. So now let's try that. In the place of h, we are replacing with 0. So now that's going to be 3 multiplied by 0. That's 0 there. So now 0 plus 6x, it is just what? 6x. So drop the limit. Now your derivative from first principle, it is just the remaining part, 6x. Understand? So now this is the derivative from first principles. So now let's take a look at the next question. Okay, I hope that was clear, guys. Now, those are just 3 marks. 5 marks, just 3 marks. So 8.2, they say that John determines the derivative at x is equals to a, because I can see here was supposed to be x. So it means they are taking the derivative at x is equals to a. So now they say the derivative of a certain function at x is equals to a. You see, x is the same as a, and arrives at what? At the answer, the limit as h approaches to 0. So now this is the same as your first principle formula, guys. It is the same as what? Your first principle formula. You have the limit as h approaches to 0. You have the h at the denominator there. Remember, I told you about this negative, that this negative came with your first principle formula. And after this negative going to the right, what you have is what? Is your original function. Always remember that what you have after the negative is what? The original function. So now this tells you now this constant here. Again, they said at x is equals to a. It means now your a there, it is what? The constant. Yeah? But this doesn't tell us now that a is 2. No, the a is not 2, but we are going to deal with that. Yeah? I'm just telling you that this part has to be what? Our original function. This has to give us the original function. So now let's see. Let's say write down the equation of g and the value of a. You see? So now what we are going to do is to say that, okay, this is the same as the first principle formula. Or I can say this part here, what you have there, it is the same as this part before we eliminate the 3x squared. So this tells us now we know the first principle formula doesn't have the radical sign. It means now our g of x has what? The radical sign. So how do we find the inside there? That's so easy, guys. Let's take a look here. So since we said that our original function has a radical sign, it means now this is supposed to be x as our inside there. Because now when we evaluate our function at x plus h, we'll have what? The square root of x plus h. And they say that this function, John determined the derivative at x is equals to a. This a here, it is the constant. So that constant is what? It's just the 4. Net. So take a look at this. So when we replace, remember x is the same as a that is equals to 4 now. So it means now that's 4 plus h. This is the same as what you have there. And what about this part here? Remember, your first principle formula, you subtract the original function. So you keep the negative outside. Your original function is just the square root of x. But now, John determined the derivative at what? At x is equals to a, which is what? Your 4. And the square root of 4 is what? Just the 2. You see how this negative 2 came from, or this 2 came from? All right. So now, guys, this tells us we can conclude and say our function g of x is just the square root of x. And the value of a is equals to 4. And we are done like that. We get those 2 marks. So now, moving to 8.3. They say that we have to determine the derivative of y with respect to x. Guys, what you see here, this is not something like a fraction. It is not a fraction. It is not something you'll say dy divided by dx. No, you don't read it like that. You don't write it like that. How do we say it? We are saying that I'm taking the derivative of what? Of my dependent variable. Dependent variable. Your dependent variable is what? Is y. With respect to what? Your independent variable. Your independent variable is what? It's x. That's why now, guys, we are saying that we are taking the derivative of y with respect to x. You see, we have to take the derivative of y with respect to what? To our x here. Meaning that if we had something like let's say p here, p, we will have to treat p as a what? As a constant, because we're taking the derivative with respect to x, not p. So whenever you see your I can now call it the denominator part that they say with respect to something there, you have to take the derivative with respect to that. And other terms there are treated as what? As a constant. You'll see as we proceed to the next questions. Yeah? So now let's take the derivative of that. So let me see, let me use this. So we are given what? We are given y, which is equals to the square root of x into 3 minus 5 all over x into 3. Can you take the derivative directly? No. Remember, now we are no longer using the first principle formula. Then we have to apply what? Now, when you see something like this, yeah, when you see something like this, they say determine the derivative of that. This is another notation of what? Notation of saying you have to take what? The derivative. So now, what are we going to use to take this derivative? We are going to apply what? We are going to apply the basic, let me write it here. We are going to apply the basic derivatives rules. What are your basic derivatives rules? Number one, you know you have what? The power rule. The power rule states that if you have something like x raised to n, when you take the derivative of your 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 function with respect to x there, this is what? This is the same as what? Drop your exponent and multiply it with your base from the same exponent reduced by 1. And another basic derivatives rule is what we call the constant multiple rule, saying if you have c, let's say c is your constant, and you have let's say x into n there. So you do what? You keep the constant outside, and then what? Take the derivative of that. You'll have x into n minus 1. Yeah? Those are what? Your basic derivatives rule. So we're just going to use the basic derivatives rule here. So now let us do that first. So once you understand this, guys, when we get to the part of what is this? The cubic functions, né? The cubic function, that's part 2 of calculus. When you get to cubic function, now you have what? You have a deeper understanding of what's really happening in calculus. Né? This is the first stage. This is your first stage, guys. You have to deal with this first. So now, we cannot take the derivative directly since there are no rules that says that we can take the derivative of a radical sign or take the derivative if our independent variable is at the denominator there. So how do we do it? So now remember that there is this rule that, okay, let me use people. So now there is this rule that if you have a radical of, let's say x into a and then b there, say what? This is the same as a x into a becomes your numerator and then b becomes your denominator. That's the first rule. And again, there is this rule that if you have like 1 all over x into a, you take the reciprocal of this. It means now you have to make this what? The numerator. So now your x now is a numerator. Since you have a positive exponent, now you are going to have what? A negative exponent. So taking the reciprocal means as writing this in different way, yeah? But keeping the base at the same. And your exponent is the same. But the only difference there is that if you have a negative sign here, now you're going to have what? A positive sign. So guys, reciprocal is the same as the different, I can say the difference of what you are seeing here, ne? That's the difference of what you are seeing here. So that's the reciprocal, and I can call this is reversible, guys. When you have something like this, always take it back, always take it back, always take it back, like that. Understand? So now it means now here we're just going to say this is why before we take the derivative, this is x into 3. We know that we have the invisible 2 there. So you left that, and this is the same as 5 times 1 all over x into 3. And then remember, this is the same as x into minus 3. So now we can take the derivative using the notation that we're given. So always use the notation that we're given. So this is the derivative of y with respect to x, our independent variable. This is going to be, remember, we're using the power rule here. It says drop what? Drop your power and multiply it with your base. Your base is going to be 1 there at the front of x. So now this is 3 times 1. That will leave you with what? 3 into x. From the same exponent reduced by 1. So it means now, let me show you how you do it. So you say what? Your exponent is 3 all over 2 reduced by 1. You'll have what? A half. So this is a half. Drop the exponent, multiply with your base. Your base is -5. So you'll have a positive 15 from the same exponent reduced by 1. You'll have what? A negative. Okay, this is x into -4. Guys, remember, now this is the reciprocal of what we have here before. It's like borrowing your money, you have to pay that person back. So now this, remember I said this is, you can take this back. So now you don't leave your derivative here. You say this is 3 over 2 all over what? The square root of what? Of x. And then plus what? 15 all over x into 4. Remember, it's the same as 15 multiplied by x into 4. And when you multiply your 15 there, you'll have something like we have there. So now this is the derivative with respect to x. So you can conclude that. Yeah? So now this is very simplified. So always leave your answer with a positive exponent. Don't leave your answer with something like this, guys. When you see something like this, a negative exponent, always take your answer to or simplify your answer further, guys. So allow me to erase this part here. Yeah? So now remember the derivative of this give us 6x. And also, guys, after using the first principle formula, always check using the basic derivatives rule. And here you apply what? The power rule, and check if you have the same thing there. Understand? So now, guys, let's take a look at the next question. This is 8.4. They say that g of x is given as that, and this is the straight line, guys. You can see you have what? You treat g as y. This is y is equal to mx plus c. So your -8 is m. Your 20 is what? Is the constant, which is the value of c. So they say that it's a tangent to your function f of x. So now, since the value of a there is positive and you have the degree is what? The degree there is 3, meaning now this is a cubic function and the value of a is positive. So you have a function that starts by increasing. You start by increasing that, decrease, and then increase that. So when the value of a is greater than 0. So they say at x is equal to 1. So the tangent happens at what? At x is equal to 1. They say that calculate the value of a and the value of b. So guys, remember that when you have a tangent to your function or a tangent to a curve, let's say that this tangent happens there, at that point, at point x, and the certain y value there. So now let's say that that tangent happens there. So what you have to know in calculus is that the gradient of a tangent is the same as what? The gradient of the curve, or a function. You can call it like that. The gradient of what? Of your tangent and the gradient of the curve. They are exactly the same, only at that point, guys. Please note this, only at that point. Means that if we have another tangent here, the gradient will not be the same, guys. So where the tangent happens, the the gradient of the tangent and the gradient of the curve at this point will not be the same as that point there. Ne? So only the gradient of the tangent at that point and the gradient of the curve, they're exactly the same only at that point, guys. Understand? So how do we solve this? Now, that's very simple, guys. Let me show you how. Now, you are going to say now, remember, you have to find the gradient of the tangent. The gradient of the curve, I mean. You have the gradient of a tangent, which is what? Negative b. So you're going to take from your original function f of x, take your first derivative there. Remember, the first derivative, guys, is always about what? Gradient. Yeah? It's always about what? The turning point or the maximum or the minimum. And that's where the tangent happens. Yeah? So your first derivative, guys, is the same as what? The gradient. So you take the first derivative, you are using the power rule, you have 3x squared and then plus 2a cfx and then plus b. Yeah? So now, this is your first derivative. It is the same as what? The gradient. So now, equate your gradient of what? Of a straight line, and then equate it to that, the curve. Because they're exactly the same as what? They're exactly the same at what? This point, x is equals to 1 there. So now, how do we solve this? How do you solve this? These two gradient there, or this your gradient of a tangent and the gradient of a curve happens at what? At x is equals to 1. So now replace everywhere there is x with what? With 1. 2 into 1 and then plus what? Plus b. So now you have minus a into what? Into 3 plus 2a plus b. So now to solve what is this? To solve b, you can make b the subject of the formula. You can say now therefore b is equals to negative 2a when you take this to your left, no? And then minus 11 when you take this to your left again. So now you can call this your equation 1. So now we need to you have to use two equations to solve, guys. Remember, when you have two unknowns, your a and the a there, you have to have two equations to help you find those missing variables. Ne? So now we also know that this x is equals to 1 is also a point where to this curve. Ne? It is also a point to this curve, and it is also a point to what? To your straight line. So since we don't know the value of a, neither the value of b, we can take this x and plug it to our original function g of x and say if x is equals to if x is equals to 1, what is the corresponding y value there? So we are going to say this is negative 8 into 1 plus 20. And the g at 1, this will give us, let's see, this will give us 12. Ne? Is that correct? Yes, 12. So now, it means now the point there, it is just 1 and what? And the 12. So we are going to take this 1 and 12 and plug it to your original function f of x. Why are we plugging it to our f of x? Remember, the missing variable a and b, they are where? At your function f of x. So plug it there at f of x. Now, so we are going to say, remember this is the same as y, this is the same as x. So when 12 or when y is equals to 12, what is y, what is x? X is 1. So 1 cubed plus a into 1 squared plus b into 1. But remember b is that, ne? So you can say 1, but forget about that now. So plus 18. So now this will give you 12 into 1 plus a plus b plus 18. So now make a substitution there. So you know b, the b there, your b, the expression of b is what? Is minus 2a minus 11 plus 18. So now when you solve for a here, you'll have just take a to your left, you'll have let's see, a minus a, that will give us a negative a. When you take it to your left, you're going to have a, and then 12. Let's see what we have here. So this is 12 minus 1 plus 11 minus 18. So this is 4, né? So a is just 4. So now to find the value of B, simply sub A is equals to 4 into 1. So we're going to say now, therefore, your B is what is negative 2 into 4, and then minus 11. So let me see what we have there. So now let's confirm that's 12 minus 1, and then minus 11 minus 18. Yes. And then this will give us negative 2 into 4 minus 11. This is negative 19. Negative 19. Guys, I think I made a mistake. So now, remember, guys, remember I said what? I said we are taking this on. Remember, I said we are taking A to the left. It means now this 12 has to be what? To our right. So now this has to tell us A is negative 4. And A will also have what? Negative 4. And then therefore B will give us what? It's just negative 3. Ne? You left 8 minus 11, that's what? Negative 3. 8, 9, 10, 11. That's negative 3 there. So for that, so your A and your B there, I just thought. So you can see A is equals to negative 4 and B is negative 3. So that's it. So now that's it, guys. So now, guys, let's take a look at this one very quickly. So now, this is given a function f of x. We have to determine the values of what? Of x, for which the gradient is what? Is greater than or equals to 0. So now, this, forget about this one there. That's not one, guys. That's the degree of what? Of the derivative. It's saying that's the same as what? The first derivative. Yeah? The first derivative. So now, we are going to take the first derivative to our function there. Using the power rule, you left 2x plus 3. And you are going to say now this is has to be greater than or equals to 0. So now solving for x, you left 2x greater than or equals to negative 3. So now therefore, divide both sides by x. You left that x has to be greater than or equals to minus 3 all over 2. Yeah? That's determine the values of x, for which this is 2. So now, this is the answer, guys, and you are done like that. Yeah. So of course, guys, you could have solved it like this, or making the sketch. Do I have to show, guys? Okay, let me show it for the sake of learning. Yeah? For the sake of learning, not for time, but for the sake of learning, guys. Remember that your original function is what? Is your cubic function. Yeah? Not your cubic function. Remember the degree here is 2, telling you now this is what? The quadratic function. So remember the quadratic function, if we were to solve the value of the values of x there, this will be x minus 2. Okay, let me say x into 4, and then x into minus 1. So it means our x intercept are what? Minus 4 and 1. And then remember, since the value of a is greater than 0, we'll have what? A smiling graph there. So if you put the face and put the eyes, you can see it is smiling. Yeah? So now, guys, remember that I told you that the first derivative is all about what? The gradient. And this is the same as finding the gradient of what? Your parabola. It gives you what? The minimum. So this x minus 3 over 2, it is what? The minimum. Why the minimum? Remember the value of a is greater than 0. So your function is going to curve or open upwards, giving you what? A minimum. So this is the minimum there. So we're going to say that x minus or minus 3 over 2, I think it's the same as negative 1.33 there. So let's say this is negative 1.33 there. So you have negative 3 over 2 there. And then this is where your turning point is. And then remember this negative 4 always tell you about what? The y value where this function cuts, the y axis. So this is negative 4. So your function, it is going to be like this. Open. Okay, let me try like this. So it's going to be like this. Then go H. So guys, it's supposed to go like this, no? Then to like that, and then see, we are not going to scale left. So now, when you take the first derivative, now what you have is what? Your straight line. You have the mx, you have what? Plus c there. You see is what? It's always telling you about the y value. So your graph is going to cut, your straight line is going to cut at y there. And then when you take the first derivative, remember, this is your original function, what? F of x. When you take the first derivative, what you have is what? Your straight line, which is going to cut, not cut it there, but it's just to cut at negative 3 over 2. That's the what I can call the x. That's now this becomes what? The x intercept of what? Of your function straight line. Eh? Remember, this is the what? The minimum value of what? Of your parabola. Now when you take the derivative, now this x, which was your minimum value or the average value there, now becomes what? The x intercept of what? Of your straight line. So now it means now your straight line is going to cut there and then at negative at positive 3. So now this is f prime. Understand? And then again, when you take the derivative of this, what you have is just a constant, which is just gonna be what? The 2. Yeah. So now, coming back to the question, guys. Again, I said I have to show you this what's really happening. So let me see if I use the highlighter there. So this say where is whenever you see this greater than or equals to 0, guys, they're saying where is your straight line? Remember, the first derivative is your straight line. Where is this straight line? Ne? Above the x-axis. Ne? Above what? The x-axis. Remember, this is the same as y. Ne? So your y is just this. So they're saying where is your function, this 2x plus 3 above the x-axis. This starts to happen where? At negative 3 over 2 going to where? To your right. That's where your straight line is where? Above the x-axis. Or since they included the 0 there, or you can read it like this, where is your function to x plus 3 on a line y is equals to 0? Remember, this is the line y is equals to 0 or above the x-axis. That starts to happen where? When x is greater than what? When x is greater than or equals to negative 3 over 2. That's where your straight line is what? It's positive. Yeah? That's where your straight line is positive. So that's it, guys. Now let's take a look at the next question. Yeah, that was a lot. Né? So now, guys, I'm just going to be quick now, since you got an idea né, of what's really happening here. So now, remember, if they say from first principle, guys, you don't have to think about it. You're going to say evaluate your function at the original value of what? Of x. It is the same as writing your given function. This, and then evaluate your function at x plus h. It is the same as saying replace everywhere there is x with x plus h. So now, that 2 there always tells you now you have the square binomial. Deal with that before distributing the trig side. This is x squared plus 2x he plus what? Plus he squared. And then distribute the 3 inside there. Since you just have degrees 1 there. So you have a linear name. So now, this is what? 3x plus 3h. Now distribute the negative 2 inside. You'll have what? You'll have negative 2x squared minus 4x he minus 2h squared plus 3x plus 3h. So now therefore this is f at x plus h. What's the next step, guys? The next step is to write down what? Your first principle formula, since you have set up the mathematical model. So of course there are no initial conditions. So now this is going to be the limit as he approaches to 0 of what? Of f at x plus h minus the original function of x, everything divided by h. And remember that he cannot be 0. So what do? We have to eliminate this h at the denominator there. So now make the substitution, guys. This is the limit as he approaches to 0 of what? Of f at x plus h is just that part there. So negative 2x squared minus 4x he minus 2 h squared plus 3x plus 3h. minus, since I don't have space there, guys. So I have to continue to the next page, or not to the next page, but continue down there. So now we are what? We are subtracting our original function. Protect, guys. So protect the original function. This is negative 2x squared plus 3x. And then everything divided by what? By h. You know we don't like wasting time. What do we do? When we distribute the negative inside, we'll have what? Negative, we'll have positive 2x squared and a negative 3x squared, negative 3x. So this tells us that the negative 2x squared and the positive 2x squared and the 3x and the negative 3x, they're going to rationalize. So what you have is just the numerator. So now this is the limit as h approaches to 0 of what? Of negative 4x h minus, what is this? Negative 2h squared and then plus 3. You see, h is common everywhere, guys. So after that step of eliminating the terms, make sure that your denominator is common. It's common in what way? You must have h everywhere. So that's the magic of this first principle for guys. It is the magic. Since h is common, that's your factor. You have minus 4x minus 2h plus 3. So the h and the numerator and the denominator, they're going to rationalize. You have the limit as h approaches to 0 of negative 4x minus 2h plus 3. Make the substitution where there is 0, you know the rule. You have to do what? Mental. Otherwise, if you show in your calculation, they're going to penalize you. So you say, therefore, the derivative using the first principle is just what? It's just the negative 4x plus 3. Why negative 4x plus 3? Remember, when you substitute 0 here, now this becomes 0. Nah? You have what? 0 plus 3, that's 3. And then 3 plus that, you have a negative 4x plus 3. And that will be it using the first principle. And when you use the basic rules, guys, you have to come back to the same thing. So now, let's take a look at 8.2. They say that we have a function f of x, which is equal to that. Calculate the average gradient at what? At point x is equal to what? That's how you read it. So now, first, you see that degree there, that's the first derivative. So we have to take the first derivative here using the basic derivatives rule. But we can see that we have what? The radical sign there. It means now we know this rule that states that if we have something like that, this is the same as a into b there. We always see that x with it's an exponent, but now becomes what? The numerator. That part becomes what? The denominator. So now let me use red. So now this means now your f of x, write it like that. So now this is the same as 3, guys, all over 2 multiplied by x squared minus 24 multiplied by x into what? 1 all over 2. You have the invisible 1, you have the invisible 2. You know you do pure maths. You're doing pure maths. You know there is invisible 1 and the radicals contain what? The 2 there. That's why if you square something like that, the 2 and the radical sign, they are going to rationalize. So now, taking the derivative of this, since we can use the basic derivatives rule, this is going to be f prime x is equal to what? 3 all over 2x1. But you don't have to see x into 1. Just leave it as x there. And then the half of 24, guys, that's negative 12 x. And then a half minus 1, I think that's negative half. Let me confirm. I don't want to make mistakes here or create errors. No? So minus 1, yes. So now this means now the first derivative, the derivative, this is 3 all over 2x minus 12 all over the radical of what? X. That's how you deal with the thing there. So now, guys, what's the next step? Remember, they say that we have to calculate the gradient at x is equal to 9. Meaning, if we continue to say at x is equal to 10, 11, the gradient will keep on what? Changing. So it is only at that point that the gradient is that value there. And only at what? At that point x is equal to 9. The gradient will be that value there. But it keeps on changing when you change the value of what? Of x. So now let's see what is the gradient at x is equal to 9. So you just make the substitution, replace everywhere there is x with 9. So minus 12 all over the square root of. So now let's see what. So this is 3 all over 2 multiplied by 9 minus 12 into the square root of 9. The gradient is what? 19 all over 2, ne? 19 all over 2. So now the f prime at 9, this is 19 over 2. Is it 19 over 2? Yeah. Yeah. So now let me confirm if this is correct. So now the this has to be positive. Remember, when you multiply this, you drop the exponent, multiply it with your base. This is going to be a positive, guys. Positive. Now I see that this doesn't make sense. So now this is positive. So guys, you see how? Okay, let me just say. This is what this is 3 into 3. Okay, guys, let me check something here. I think again I made a mistake. I don't know what's happening. Now, guys, let me just deal with this first. See, I made a lot of mistakes here. Remember, how do we deal with this thing, guys? We say when we take the derivative, we drop the exponent, multiply it with the base, which is just 3 over 2. So 2 times 3, that's 6 divided by 2, that's what? That's 2x into what? Not 2. Remember, 6 divided by 2, that's 3. So you say 3, from the same exponent reduced by 1, you left that, then minus, or you left plus 12 into x minus 1 all over 2. So this is 3x plus 12 into what? Into the square root of x. And now this is first derivative. So at x is equal to 9. Let's see the gradient there. So you see, guys, how you have to be careful with the derivatives. So this is 12 into the square root of what? Of 9. See, now this makes sense. This what makes sense. It's just the two one. That will be it. So guys, I'm just going to erase this partner for space. So now let's take a look at 8.3. I'm just going to deal with this here. They say that a function g of x is equal to a raised to an exponent of 2 plus b all over x has the minimum value at x is equal to 4. The function value at x is equal to 4, it is 96. Calculate the value of a and the value of b. That's very simple, guys. Every time you hear about minimum, every time you hear of minimum, maximum, guys, think of the first derivative. Remember, the first derivative is all about what? The gradient, and it's all about what the turning point is starts. So now it means now we're going to take the derivative of what? Of our first function, of our function there. So taking the derivative of that, and remember, this is the same, g of x is the same as what? Let me write it this nice. This is the same as b multiplied by x minus 1. So when we take the derivative there, you'll have what? There is 2 there. So this is will be 2ax and then minus b all over x into 2. Reduce by 1, you have x into negative 2. So then take it back, you have something like this. Yeah? So now, remember, to find whenever you want to find the minimum, guys, you agree with me that you'll take your first derivative and then equate to what? To 0. So when we equate to 0, this will be this, and then at x is equal to 4, that's when you have what? Minimum. So you just make the substitution there. At x is equal to 4, you'll have minus that into this is 4 squared, that's 16, right? 4 squared, that's 16. So now, and this turns to be that's 8 what? 8a, yes, 8a. So 8a, remember you left 2 into a, and that 4 times 2, that's 8a. So now to make, or let's make b the subject of the formula, you can simply multiply both sides by 16. When you multiply both sides by 16 there, you left the 0, and let's do that also by taking a to, or by taking b to our left. We're going to have b is equals to what? Is equals to 8 times 16 What is that? The one something. 8 times 16. 64. That one time is, oh, that's 128. Okay, sorry for that. So that's negative, oh, that's 128a. Now, remember, we're taking, when you multiply here, the 16, they're going to rationalize this times this, that's 0 there. And then we take this to your left, you're going to have b into that. And you can call this equation 1. And we're told something that the function value is equal to what? 96. This is the same as saying to our g of x, when not the derivative, to our g of x, when x is equal to 1, what is the y value? The y value is what? Is 96. This is 96. So I'm just going to say from our original function, when x is equal to 4, y is what? Is 96. So 4 squared, that's what? That's 4 times 4, and that's like 16. Now 4 times 4, that's 16, guys. That's not 8. The same 4 multiplied by 4, that's 16. 4 times 2, that's 8. Understand? So now this 16, a plus b all over 4. You can simply, I don't know, but okay, let's just make the substitution. Let me just bring that back. So you have 96 is equals to 16a. Your b is 128a all over 4. And then let's see 128 divided by 4. Divided by 4, that's 32. So you have 96 all over 16a plus 32a. So now let's see what you have there. You'll have 96, which is equals to 48a. 16 plus, you'll have 16 into, let's say, 32 there. 6 plus 2, that's like 8, and then 48. Yeah? So now 48, 96 divided by 48, let me see. 96 divided by 48. That's true, né? What do you think about that? So now a is just 2. Yes, it makes sense. You have 6 divided by that, that will give you 2. And then your a is just the 2 there. Now, how do we find b? We're just going to say a and plug it to this part there. So now it tells you now you have what? 128a into 2. And then this will give you what? Let's see what is b. So 128 times 2, that's 256. That's a lot. 256. No, that's 256. Okay, so now we're back. So guys, from here you left b is equal to 256 now, and that's it. So now let me just write that down. So our a is what? Is just the 2, and the b is 256. We are done. So now guys, the next question. Let me just use this one there. So 8.2, they say that we have to determine the derivative of f of x if we have something like that. So now guys, you have the 2. The 2 tells you have the square binomial. So for 8.2, we're just going to say f of x, because we cannot take the derivative directly. We have to do something first. So now that's the same as expanding, né? Your brackets there, you left 4x, and then you left 2 to that, multiplied by x into -1, and then remember you left a -1 here, and then again you left what is this? You left negative x into -1, multiplying 2 into what is this? X is there. Left something like this. So now this part here, remember this is 2 into x a half, is, remember a negative into that, and this is the same story here. So we're just going to multiply this by 2. So now let's see. Remember you have the same base x and x, you need to add the exponent. So it means you, let's say, a half minus 1, that's negative half. So it tells you you'll have negative 2x into negative a half. Missing that by 2, it means you'll have negative 4 into negative 4 into what? X into negative a half. Then the remaining part there, this is this part. This is this part here. It will give you a positive. Negative times negative will give you a positive what? X into negative 2. You have the same base. You add the exponent, you'll have negative 2 there. So now, guys, remember I told you that you can take the reciprocal of this, which is x into negative 1. Yeah, don't be alarmed. So now, taking the derivative of that, we are going to have what? 4 plus 2x, and then let me see, I think it is going to give us negative 3 over 2 minus 1. Yes, negative 3 over 2. So this is negative 3 all over 2 minus 2x minus 3. I'm using the power rule. So go further. You'll say 2 all over the square root of x into 3 minus 2 all over x into 3. Yeah, you are done like that. So therefore, this is the first derivative. Yeah? So now, guys, they say now for 4 marks. Yeah, for 4 marks. So now let me see. I'm just going to use this one. Let me just use the light one. Yeah. So now they say that we're given a cubic function. You see the degree there. It is 3, 2, and then 1. That's what a cubic function. So when you take the derivative of your cubic function, you get what? You get the parabola, which is the quadratic. When you take the derivative of your quadratic, you get what? The straight line. Understand? So that's how it reads. So now this is determine the interval for which it is concave up. Since the value of a is greater than 0, meaning positive, your function will start by increasing, decrease, and then what? Increase. The concavity happens where? At the point of inflection. Remember, point of inflection, that's where you what? You have the concave. That's where your graph is either concave down and then concave up. So, guys, what I want you to get from this is that when you hear about the word concave, not concave up, but just concave. When they say that, okay, let me just say, when they say f is concave, think of your second derivative is equals to c. That's all about concavity. When you hear about concavity, your second derivative is what? Is 0. So now we're just going to say now let's take the first derivative. The first derivative is all about the minimum and the maximum. No? The first derivative 9 times 3 or 3 times 3 there. That's 9. I'm using the power rule. So minus 6 x plus 6. And then the second derivative, you'll have 18 minus 6, 18x minus 6. I said you have to equate this to 0 to solve for x. For finding the x where this is not where this is concave up, but find the value of x where the graph is either concave up, down, or concave up. Understand? So to solve the x, you see 6 into 18, and then x divided by 18 both sides. So divided by 18 both sides, this is the same as 18 or 6 goes into itself once and then to 18 3 times. So now this tells you that this 1 all over 3 there is where is in the middle, where it is either concave down like that or concave up. So now they're saying where is the function what? Concave up. Ne? So it means now, let me just sketch it as ne? So let's pretend like this is where the concavity is. Yes, this is where the concavity is, ne? The 1 all over 3. So now when we remember, you read the graph from left to what? To your right. So going to the right, you have what? You have the concave up. So it means now when you start having positive 3 and then 2, 3, 4 to infinity, That's why your graph is what? Is concave up. So you're just going to say now, our conclusion is what? Is to say x has to be greater than what? 1 all over 3. Since they said the interval, you can say that therefore x is an element of what? Not including 1 all over 3, but from 1 all over 3 to what? To positive infinity. And infinity is not included. You have that 4 marks like that. So now let's take a look at this one. So, okay. So now they say now we're given a function g of x. We have to deal with this from first principle. So remember, evaluate your function at the original value of x. So it's like writing down your given function and then evaluate your function at x plus h. So this is 1 minus 4 into x plus h. The 2 tells you have what? The squared binomial. So deal with that. You'll have 1 minus 4 x squared plus 2x h plus h squared. So distribute the negative 4 inside. You'll have negative 4x squared minus 8x h minus 4 h squared. Therefore, this is f at x plus h. Write down the first principles formula. This is f prime of x, not f prime base. And this is not f prime. This is g of x, g of x. Since the function that we're given is what? G of x. So we're just going to say g prime of x is equals to not f of x, but g at x plus h minus what? G at x. Everything divided by h. H cannot be seen. So to make the substitution there, you'll see what? And again, we forgot about the limit here. So always, guys, there's a limit. Né? So now when we make the substitution, this is going to be the limit. Let me make a space. This is going to be what? The limit as h approaches to 0 of what? G at x plus h is just 1 minus 4x squared 8x h minus what? 4h squared. Minus, protect the original function, which is what? 1 minus 4x squared. All over what? The h. You know we don't like wasting time. You need to distribute the negative side, you'll have minus 1 plus 4x squared. So this tells you now the 1 and the 1 rationalize the negative 4x squared and the positive 4x, they're going to rationalize. So now you just have the limit as h, which is to 0, of the remaining part, which is the negative 8x h minus 4 h squared, everything divided by h. So now you can see that h is common there, the numerator. So deal with that. So it means h is your vector. So h is your vector, so that you can eliminate it with the denominator. So you'll have 4h over h is rationalize. You'll have the limit as h approaches to 0 of what? Of the negative 8x minus 4. So when you reach this stage, guys, you'll have to make the substitution or replace in the place of h with 0. So that's going to be negative 4x times 0, that's negative 0. 8 minus x minus 0, that's nothing. Just negative 8x, ne? So you're removing nothing. So this is f prime, not f prime. So therefore, g prime is just what? Drop the limit is just the negative 8x. When you use the basic derivatives rule here, you have to get to the same answer. So now, this was 7.1.1, and our answer is just what? Negative 8x. So now they say that has calculated the gradient of f at x is equals to 2. So I think they made a mistake here. This is g prime of x. G of x, ne? The g, not x, f but g. Ne? Supposed to be g. Agree they gave us g as our function. So now guys, they say at x is equals to 2. This is the gradient, ne? So what you do is just to make the substitution, say g prime at 2 is negative 8 at 2, and the g prime at 2 give you what? Negative 60. And this will be what? Your answer. So therefore, this is your answer. So now I can say the g at 2, it is just what? Negative 60. So now let's take a look at the next question. Determine the derivative of f of x. We cannot take the derivative directly, so we have to do something. So this is the same as x into 2 all over 3. Remember, I told you can write this as what? As a power or exponent. When you have something like this, a radicals, you can write this as what? As a power or exponent. And then this is the same as 1 all over 4 times x, not x, but times 1 all over x into 4. This is the same as x into 2 all over 3 plus 1 all over 4 into x minus 4. You take the reciprocal of that. It's the opposite of what you're seeing, guys. So now let's take the first derivative, or the derivative, not the first derivative, but the derivative. So when you take the derivative here, you have 2 all over 3 into x. Now let me see. What is that? So you say what? You say 2 all over 3 minus 1. Left what? Negative 1 all over 3. And then negative 4 times 4 there. So quarter, you left what? You left negative x minus 5. You left negative 4 divided by 4. That's negative 1. Invisible 1 there. So you're not done. To take this further, you left this x into, and then you left 3, then 2x. Don't forget about the 3 here. And then minus what? Minus what about this part here? It should be minus 1 all over x into 5. And you are done with that. So now I'm just going to erase this part here, for space. So now moving to the next question. This is what is this? This is 7.3. You see that we have a g of x. Determine the value of a if it is given that this is not the derivative but the inverse. Once you have a negative 1 there, that's what? The inverse. You see, now this is an invisible 1. But when you see that prime there, that's not the 1 but the degree of a derivative. So this is the inverse. And then this is what you see here. That's what? The derivative. So now I'm just going to, let me use another color here. Let me use black. So now this then I have to determine the value of a. So guys, first let's take the inverse of h of x. So we have h of x, which is equals to ax squared. Remember, when you take the inverse, guys, you just swipe the place of x or y becomes x, and x becomes what? Y. Like this. That's the inverse. So now h of x, remember, is the same as y, which is equals to ax squared. And then we still have that. Okay, let me just keep it like that. So now when we take the inverse of this, before we take the inverse, let's just delete this part here. So to make x the subject of the formula, it means now x is what? Is a square root of y all over a. Again, you'll divide by a, so you'll have y over a, and then square both sides. You'll have plus or minus square root of what? Of a. But they say that x is to be greater than 0, so meaning that here you'll just have a positive radical sign there. And this is not 9, guys, this is a. So now the inverse is going to be what? The inverse is going to be y is equals to what? The square root of okay, let me just write it here. This is y is equals to the square root of what? Of x all over a. So before, I just work out x, or make x the subject of the formula, and then swipe x and y. Understand? So now, remember, x was greater than 0. So now this tells us y has to be what? Greater than 0. That's the inverse. So now this becomes what? The inverse. So you can see now this is the inverse. So now this is the inverse. They say that the inverse is to be what? In the place of x, they replace it what? With 8. So we are going to say now this is y is equals to the square root of 8 all over a. Yeah? And this has to be equals to what? To the derivative of what? Of our original function h of x. So we just taking the derivative of that. Um, so taking the derivative of h of x would be what? Will be 2a and then x. And then in the place of x, we are going to put what? To replace with that with 4. So it means now we have what? We have the square root of 8 all over a, which is going to be what? The 2 into 4. 4 times that will give us 8a. To solve for a, simply square both sides to get rid of the radical sign. So we will square both sides that. The 2 and the 2 rationalize. Now you have what? Now you have 8 over a all over 8 squared. This is the same as 8 multiplied by 8, and that's 64. 64a. So now to solve for a, guys, you can simply multiply both sides by a. Right? So the a and the a here will rationalize with that 8 into 64a squared, like that. And then to solve for a here, you'll divide both sides by 64, 64, and then the 64 and the 64 rationalize. You'll have what? You'll have a into the square root of 8 all over 64. So now let's see what is that. So square root of what is this? And remember, guys, this is not going to be the square root, but a cube root of what? Of 8. No. Something is off here. Remember, you also have the square. Remember, this is going, you left the, this is called the power of a power rule, guys. You distribute the power to both of this inside there. So it means now you have the 8 squared, and then when you multiply both sides by the a, it means now you're no longer dividing the, so now let me remove this, guys. Sorry for confusion. So now you have what? You have a into what? Into 64a cubed. Next, when you multiply by 8 there. So now it's still the same thing. Divide both sides by 64. So now you'll have what? You'll have a into the cube of what? Of 8 all over 64. So this is 64, which is just a half. So a is just a half, and you are done. That's the solution, guys. For 6 months, take your calculator and say 15 divided by 150 is 100%, and see how much you will have got, or percentage that we have got from this or this differential question. So now, guys, we're just going to look at the next question, and this is still the same question that we did. This is still the same one that we did here, 8.3. Now you see you have x, and they're talking about the minimum. So this is still the same thing. So you remember a one here was okay. Remember the b was 256. I think the a was 2 years. So now, before we get to that, now let's deal with this cut. So now, guys, remember I told you something. I told you before, or before we tackled the questions, that when they say take derivative with respect to x, the other variables, you treat them as a constant, meaning pi. Pi, guys, is a number. Pi is the same as 3.12, blah, 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 blah. So pi is a number, guys. You don't treat it as like it's a variable or something like that. It's a number. So now we cannot take the derivative directly. So it means we have to do something. Yes. So this is the same as 4 multiplied by x. Remember, you have invisible 1 and divisible 2. Make that the exponent. This is the same as 8 multiplied by x into, you have the invisible 1 and the divisible 2. When you take the reciprocal, you have negative 1 over 2, guys. Before, it is something like this. When you take the reciprocal of this, it will be x into negative half. Ne? So now you'll have what? A negative 8 times x into a negative half. And then plus what? Plus pi x into the 3 there. So taking the derivative using the notation that we're given, this is dy with respect to x. There, drop the exponent, multiply it with the base. This is 2x minus a half. The half of 8, that's 4x minus 3 all over 2. The derivative of this, it is what? It is going to be, what is this? It is going to be 3 pi x into 2. And then you are not done. So this is the same as 2 all over the square root of what? Of x plus 4 all over the square root of x into 3. And then plus 3 pi into x, and then you have the 2. Remember, pi is a number, guys. Yeah? 3 times pi there, it is a number. Understand? So that's the derivative. And remember, for 8.3, your a is 2 and your b is 256. Yeah? You know how we deal with that. We dealt with that. Yeah? So now, first principle formula. So okay, so the first principle formula, guys, you remember you first evaluate your function at the original value of x. So this is the same as writing down your original function and then evaluate your function at x plus h. It's just, this is the same as replacing everywhere there is x with x plus h. So now you have the square binomial value. So that, with that, you'll have negative 2 into x squared plus 2x h plus h squared plus 6x plus 6h when you distribute the 6 inside. So now distribute the negative 2 inside, you'll have negative 2 squared, negative 4x h negative 2 h squared plus 6h or x, sorry, then plus 6 h. So therefore this is f at x plus h. Write down the first principle formula. F prime of x is equal to the limit as h approaches to 0 of f at x plus h minus our original function f of x, everything divided by h. H cannot be 0, meaning we have to eliminate the h at the denominator there. So now make the substitution, guys. So this is the limit as h approaches to 0. The f at x plus h is just that part there, this part. So this is it. 6x minus your minus what? Your original function, protect. So everything divided by what? By h. So you know we don't like wasting time. It means now this part and this part we'll have to rationalize after distributing what? The negative inside the ne? So now and the 6x and the negative 6x, they're going to rationalize. So now you just have the limit of a function, or the limit as h approaches to 0 of the remaining part, which is negative 4x h minus 2 h squared plus 6 h all over what? All over h there. So h is common. That's your factor. Factor that out. So if the limit is h approaches to 0, this is not L, but h, guys. H, guys. Ne? So h becomes your factor there, common factor. So you'll have something like this. And then you see now we rationalize what there, the h there, the numerator and the denominator. So now this means we can take the limit after this there. So take the limit, you replace in the place of h with 0, you have what? 0 plus negative 4x, that's negative 4x plus 6. So therefore, the derivative from first principle, it is just negative 4x plus 6. So now, guys, 8.1. And then remember the derivative here, this gave us negative 4x plus 6. No? So 8.2, guys, can we take the derivative directly? Yes. Everything is in a standard form now. No? So now this is y. So first, let me just write down what we are given. We are given 2x squared plus a half into x, and then there was 4 minus 3. When you take the derivative of this using the notation, always use the notation that you are given. You have, using the power rule, you have 4x plus 2x to the 3. Treat this as a constant since you are taking the derivative with respect to x. So are you done here? Now that's it for 2 marks. So now, how are they going to mark you? They're going to say this is 2 marks. Understand? So now, coming to this one, see this 4 marks. You have to do a lot of work here. So this is 8.2.2. I'm just going to first write down what we're given x cubed minus 5x squared plus 4x, and then x minus 4. Guys, you have x, x, x. X becomes what? Your fact. Always when you hear x, 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 that's your fact. Factor that out. We have to eliminate. And in this case, they should have said that, okay, us or we should say x cannot be 4. It means you cannot just, or just, what is this? Take the derivative like this, ne? So it means you have to do something in order to eliminate x minus 4. Because 4, when you place 4 there, 4 minus 4, now everything becomes 0. So now, since at the numerator you have x as a common factor, factor that out, you left what? The parabola now, the quadratic function. You still have to do a lot of work since this and this. Guys, you cannot say x and x rationalize. It doesn't work like that. Yeah? This covers everything there. Understand? If it was x and then x into blah 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 blah, now you can rationalize. Understand? So now you keep the x. This is the same as x into minus 4 x minus 1 all over x minus 4. So now the x minus 4 and the x minus 4 rationalize. You have what now? You have f of x, which is equals to what? X into x minus 1. If you still don't understand what I did there, I just wrote this as if we're solving for x net. Writing this is the bracket form. So this x times x give you x squared. X times negative 1 will give you negative 1. This negative 1 minus negative 4x will give you negative 5x. Negative 4 times negative 1 will give you 4. So now, before you take the derivative, deal with this, you have x squared minus x. You see why this is 4 marks, guys. So when you take the derivative here using the notation that you're given, you have 2x minus 1, and this will be your answer. You understand? Okay. And then, guys, you see this one here, it is the same as what we did, but I'm going to show you in this one because this is a different one, but it's still the same thing, guys. Yeah? You still have to stick to the. Let me show you. You see this one, where is that? You see, look at this one, picture this one in your mind. Yeah? Picture this one in your mind. In this one, you're given what? The variable of g of x, but you don't have what? The y-intercept or the y value. This one, you're given the y value, the x value, and they're looking for what? A and the b. And they're saying it's a local minimum. And remember the last question there, previously, it was also what? A minimum. And now they told you about something that is a turning point. And we know once we hear about a minimum, guys, we know it is a turning point. Yeah? So I'm just going to erase this part so that we can deal with those other things there. So how are they gonna mark you here? They are gonna mark you here, and they're gonna mark you here, and they're gonna mark you here, and they're gonna mark you here for taking the derivative. That's what 4 marks. Yes. Yeah? So now I'm just going to erase that part, man. Okay, so we are back now. So for 8.3, I hope you can see the question there. Guys, don't forget to subscribe and like, né? And also comment if you have something to say. Or simply say thank you, guys. Simply thank you. I will appreciate it so much. Né? So for 8.3, guys, they say that a tangent to the curve Okay, you see, this is a curve. The degree is 2. So they say it is drawn at point what 2 and the negative 3. They say that a straight line is parallel to what? To this tangent. They say a tangent is drawn to the curve. So let's say since the value of a is positive there, so you have something like this. So let's say that that's a tangent. And they say it's a straight line parallel to this tangent. So remember, a parallel line has to be the same like this, but they shouldn't what? Meet. Ne? So that's a parallel line. So this line is parallel to the tangent there. So what do we know about parallel lines? They have what? The same gradient. So they have what? The same gradient. So you can say M1 is the same as M2. You can call this the M1, M2. They have the same gradient since you have what about parallel lines. Ne? About parallel lines. So now guys, they see that it is a tangent passing through the y-intercept of what the curve. It means now we know something about the now they're going to credit us. We're going to say this is y. Remember, we're going to find what determine the equation of this that straight line. So this is tells us since it is a straight line, it is going to take the standard form of y is equal to mx plus c. This c we are told is that the straight line is the straight line parallel to this tangent line there passing through what y-intercept of what the curve. The y-intercept of the curve is negative 5 there. Remember, the standard form of this is y is equal to ax squared plus bx plus c. C is what? Your y-intercept or your y value there. So now this tells us that this is y is equal to mx minus 5. We need to find the gradient. How do we find the gradient, guys? Always remember. Always remember. The gradient of a tangent and the gradient of what? Not the gradient of a tangent, the gradient of what? The curve and the gradient of what? Of a straight line. They're what? They are the same at what? At this point 2 there. X is equal to 2. I told you before. You still remember that? Yes. That's our approach. Since we don't know the gradient of this tangent line, how are we going to find this gradient of a tangent line? That's very simple, guys. We can take the derivative of our function here, f of x, because we know that since if we can take the derivative of this function, that would be the same as what the gradient of what. Remember, when you take the derivative of there, that's what the gradient. So that gradient will be the same as the gradient of what of the tangent. At what? At that point, x is equal to 2. Now let's deal with that. So we can say our function y, well, let's take the derivative there. We're going to have what? 4x using the power rule minus 3. This tangent line or this tangency happens at x is equal to 2. Don't worry about that y value there. This y value, they got it after they say, okay, if our x is 2, what is y? Understand? So now the gradient, or we are going to find the gradient at x is equal to 2. Ne? At x is equal to 2. Remember this whole thing there. This one. Remember, they said determine the gradient at x is equal to 2. The gradient at x is equal to 2 is what? It's negative 16. So we are going to say what is the gradient at x is equal to 2 there. So remember this y prime here is the same as the gradient. What is the happening now? Okay, let me just. Okay, so now this is our gradient. When we take the first derivative, guys, always remember, note that. Always remember that it's the same as what? The gradient. So this is the gradient. So now let's see what is the gradient at point x is equal to 2. So I don't know what's happening. Let me deal with it. Okay, so now the gradient at x is equal to 2. Let's see what is that. Okay, not that. So this is 4 and it's 2. That's 8 minus 3. That's what? That's 5. 5, 6, 7, 8. That's 5. So now therefore the gradient at x is equal to 2 is what? It's just 5. So now this gradient here, the gradient of the curve is the same as the gradient of a straight line, which is what? The tangent. So it means now your straight line is what? Is equals to m is equals to what? 5. And this 5 is the same as what? Is the same as a line, that line parallel to what? To this tangent. So therefore, y is equals to 5x minus 5. And this is the equation of what? Of a straight line parallel to the tangent passing through y intercept. Don't forget to subscribe, guys. We are not done. So now it is given. This is another or the next following question. This say that it is given that g of x is that has a local minimum at point x is that. Okay, let me use red. Let's this. Yeah. Okay, that's very simple, guys. Now, what are we going to do? We know this point here. It is also a point to our curve. That's our first step. Now, we are going to say now, okay, this is 17. This is y. So y it is 17. So now a into what? Into 2. Into 3 minus 24 into negative 2 plus b. Guys, this is very simple. Ne? This doesn't have to be tricky to you. Ne? Or you shouldn't find it very difficult. This negative 2 and the 17, it is also a point to your curve. Ne? So now you are going to say, okay, if y is 17 and x is negative 2, let's see where this takes us. Ne? That's our first step. So now this is 17 into what? Negative. This is negative 2 times negative 2. And then this will give us, okay, let me just first delete this. 2 times 2 times 2 times 2, that's what? That's 8. And this will give us negative 8 into 8. Why negative 8? We know 3 is an odd number. So whatever thing you put here, whether it's a negative or positive here, okay, let me say stick to the negative. If it is a negative number that you put there, your result is what? Is a negative, since it's just an odd number. And 2 to the 3, that's 8. This one here, this is positive 48 plus b. And then now let me see, I will need a calculator here. So this is 48 minus 70. That's the 2-1. Eh? So now this is 0 is equals to negative 81, negative 8a plus 81 plus b. Let me see what I did there. 48 minus 2, let's put that to the left. So now let's make b the subject of the formula. So therefore, let me make a space. So I'm just going to write it here. E has to be what? 8a into negative 31. This is our this is our equation 1. You understand? I hope you understand. So now our next approach is to say, okay, once we hear about the local minimum and the turning point, we know that if we can take the first derivative and equate to 0, that's finding what? The x-intercept at the turning point. So taking the derivative of our function g of x, we are going to have what? 3ax squared minus 24x. And then the derivative, or remember b is a constant, the derivative of b will be just 0, and this one will be negative 24. So now, this is our x-intercepted at the local minimum. So you make that substitution. Remember, you have to let this equals to 0, né? And then also simultaneously make the substitution. So now this is going to give us an even number. 4 times 3, that's 12. So we have 12a minus 24. So to find a, you'll simply take this to the left. So therefore, your A is what? Is just 2. Yeah? 24 divided by 12, guys, that's 2. So A is what? Is 2. To find the B, you say B into 8 and then 2 minus the what? I don't have to overthink. Yeah? I'll say 8 times 2 minus 81. This will give you what? Negative 15. So therefore, your B, it is negative 15. Just like that, you get those full 5 marks, guys. That's very simple, né? And again, don't forget to subscribe, guys. Oh, wow. Okay, guys. Now, to the next question. For first principle, we don't have to think about it. So 9.1. And our answer here is to be. So let me deal with this using the basic derivative rule. It means it has to be 3x minus 2. This is what we should find as our product. So now, we evaluate our function at the original value of what? Of x. So this is going to be what? 3x minus x squared. And then evaluate your function at x plus h. This is going to be what? 3 into x plus h minus x plus h. Put the negative outside, guys. So now, you'll have what? 3x plus 3h when you distribute inside it. And then now you'll have to deal with the squared binomial. And you'll have to find that. And then when you distribute the negative inside, you'll have this. Okay, you have something like this. So therefore, this is f at x plus h. What's your next step? You write down the first principle formula. F prime of x is this limit as h approaches to 0 of what? Of f at x plus h minus f of x. Everything divided by h cannot be zero. So now make the substitution. A limit as h approaches to 0 of 3x squared plus 3h minus x squared minus 2x h minus h squared minus, protect the original function, 3x minus x squared, everything divided by h. So now, when you distribute the negative inside, you'll have negative 3x plus x squared. So this, and did I miss something? Where is this negative 3x squared coming from? I can see that I made error there. So now, the x squared and the positive x squared are going to recognize. So now you have what? The limit as h approaches to 0 of the remaining part of the 3h minus 2x h minus h squared. Everything divided by h. Look at the numerator. H is common. That's a fact. So h is a factor. You'll have 3 minus 2x minus h. H, the denominator and the numerator, they are rationalized. Have the limit as h approaches to 0 of 3 minus 2x minus h. Make the substitution in the place of h. So that's 0 there. So now just have that part. So therefore, this is f prime of x. Using the first principle formula, just 3 minus 2x. Is it the same thing that we have before? Yes, it is. So you see, using the basic derivative rule, you have to come back to the same thing. So 9.1.2 x. Determine, okay, I'm just going to write it here. Determine the average gradient between x and 3 bed. That's very simple, guys. They say that determine what the average gradient of f between x and between 3. They're not saying you should have to say 3 minus 1, then blah, blah, blah. This is your this is your gradient. Let's find the gradient at x. At x is equal to 1. So this means this is at x is equal to what? 1. So you'll have what? 3 minus 2 into 1. 3 minus 2, guys, that's what? That's 1. So this is the gradient at x is equal to 1 is just what? It's just 1. So now the gradient at x is equal to 3. It is what? It is 3 into minus 2 and then 3. This is negative 6. So that will give us negative 3. So that's it with that. part there. You are done like that. Understand? So to the next question, this part. So allow me to raise. Okay, before raising, I think I still have space. So now 9.2.1. They say that we have to take the derivative of this. Can we take the derivative directly, guys? Answer is no. Why? And you cannot say that this divided by this. Doesn't work like that. This covers the whole or the entire expression of the numerator there. So it means now you have to decompose or split the numerator with the denominator. That's 8 all over 8x to 2. Since I said it covers everything there. So this is what you will have. And you take the derivative, no. This will give you 1 there. So this is 1 all over x squared minus 3 all over 8. You have the same base x and x. Subtract the exponent, you see 6 minus 5, the top exponent minus the bottom one. So this is x into what? Into 1. You don't keep it there, guys. Remember, when you split there, you'll have 3 over 8x divided by that. Will give you what? 1. This is the same as saying from 6 subtract 5, you'll have 1. And from 5 subtract 6, you have nothing there. Understand? So you just have 1 like that. So this is the 6 minus 1 minus 5, that's 1. I hope you understand. So now taking the derivative of this, you'll have what? You cannot take the derivative still, guys. You still have something like this. Take the reciprocal. The reciprocal is the opposite of what you're seeing. So this is x minus 2. That's the reciprocal. Is the what? The opposite of what you are seeing. That's what the reciprocal. So now, when you take the derivative of y with respect to x, your x is your independent variable. You have to drop your exponent and multiply it with your base, which is 1. You are having 2. And then from the exponent, same exponent reduced by 1, we'll have negative 3. And then 1 times that, you'll have negative 3 all over 8. From the same exponent reduced by 1, you'll have x raised to an exponent of 0. X raised to an exponent of 0 will be 1. There's this rule that states any number raised to an exponent of 0, it is 1. 1 times that will give you this. You're not done. Take this further, you'll have x into 3 minus 3 all over 8. Therefore, this is the simplified derivative of this, of your 9.2. Let's take a look at the next question. I'm just going to erase this part in this. It's all big here. Okay, so now moving to the next question, 9.2.2. They say that we have to take what? The derivative of this. So we are given something like this, guys. I'm just going to first write it or write what we are given. This is 9.2.2. We're given dx there. That's the another notation of saying take the derivative of the inside, which is this, plus what? Plus 1 all over x, and then plus 2. We take the derivative directly, that says no. Follow my steps, guys. Yeah? So follow what I have to teach you. So now you keep the dx and say, how can I write this? You say, okay, the opposite of this is to write this as an exponent. So 2 all over 3, that's an exponent now. The opposite of this is to take the reciprocal. The reciprocal is the opposite of what you're seeing. So this is plus x into negative 1. You have the invisible 1 there. And then plus 2x. Take the derivative of the inside. You say it squares 2. Then the derivative of this is 2 all over 3. From the same exponent reduced by 1, I think that's negative 1 all over 3. No? Negative 1 all over 3. 2 all over 3. Subtract 1. So this is negative 1 all over 3. And then drop the exponent, multiply it with the base of the same exponent reduced by 1. You have that. And then plus 2x. Are you done? Nope. So this is 2 all over 3 times x into 3. You have the invisible 3 there. And then what? And then minus 1 all over x squared, then plus 2. That is becomes your derivative. So now, guys, 8.2.1, we are given y, which is equals to 1 all over 20, okay, 5, not 5, 2x to the power 5 minus 7x plus 4 to 3. So always, guys, follow what I'm teaching you. Never go wrong. I explained before that we are taking what the derivative of our not independent, but the derivative of our dependent variable with respect to what to our independent variable. Your independent variable is what is x. Your dependent variable is y. So now, since you are taking the derivative with respect to x, everything in that entire expression, you treat it as what? As a constant, except what? Your independent variable. So your b, you treat it as what? As a constant. You don't have to worry about b, guys. So when you take the derivative of this, before taking the derivative, you have to take the reciprocal of this. It's the opposite of what you're seeing. So this is 1 all over 2 times x minus 5 minus 7x plus 4b into 2. Guys, I don't want you to get it wrong. I want you to get full marks from differentials. Again, we're still on part 1. This is differential. And after this video, I'll make another video for cubic functions. So now, we are taking the derivative of what? Of y, this one, which with respect to what? To our independent variable which is what? The x. So you treat the other variables as what? As a constant. So it means now the derivative of this, it is just what? Negative 5 all over 2 x into negative 6. The derivative of this is your independent variable. So we're taking the derivative with respect to x, so this is negative 7x. Is this respect to x? No. You treat this as a constant. The derivative of a constant is 0. So therefore, the derivative, you can go further and say this is 2 times x into what? Into 6. And then what? Minus 7. And this will be your final answer. Therefore, this is the derivative of y with respect to x. You see, just have x after this and the constant 7. Since we took the derivative of that, gave us a constant. You understand, guys? Please don't get this wrong. So now, looking at this one, you cannot say this, blah, 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 blah. This is how you treat this. So let me see, do I have a space? Okay, let me use red. Red. Okay. So guys, you have something like this now. Remember, you can write this, since you have a single term, split it with the numerator. So this is 5 into 4 all over x into plus 3. Remember the square root, you can say x and write it as an exponent all over x into 2. 4, or you can say 4 minus 2, that's 2, and then to that you left nothing there. So it means now your y is just what? 5x into 2. Understand? Or you can say, okay, let me use the quotient of powers. It says if you have the same base x and x, subtract the exponent. You say the top one minus the bottom one. 4 minus 2, that's 2. And then you left 3. You still have something like this. Half minus 2, that's what? Half minus 2, half minus 2. So let's treat this, you can say, let's multiply this by 2, that, so you left 2 into 1 minus 4. This will give you negative 3 over 2. So the answer there is negative 3 all over 2. So this is x into negative 3 all over 2. If you don't believe me, let's try it using the calculator. Half minus 2 negative 3 over 2. You see? That's why I say follow what I'm teaching you. So now, can we take the derivative here? Yes, using what? The power rule. The derivative of y with respect to x, it is going to give us what? 10 x, and then negative 3 times 3, that's 6, not 6, that's 9 divided by 2, so negative 9 all over 2, and then this one negative 3 all over 2 minus 1, this is the same as 2, multiply top and bottom by 2, and then this would be negative 3 minus 2, that would be negative 5, so this is x into negative 5 over 2. You cannot compete, guys, with maths. Uh-uh. So now, guys, look what's really happening. This is not 16, that's 10. Eh? So how do we deal with this? Are we done with our derivative here? We have to go further. Eh? So therefore, our derivative of y with respect to x what will be 10x minus 9 all over 2 times x into 5. You have the invisible to that here. I don't have to write it. No, you're doing pure maths, man. 3 times 3, guys, that's 9, not 6. Are we done? Yeah, boss. Let's take a look at the next question. Okay, this is a trial question paper for Romani Pompo. These are trial question papers, guys. November, June, they're all here, guys. I'm preparing you for trial, uh, for even your final exam, and also next year for those who'll be doing G12 next year. Not those who are repeating. No one is going to repeat. No, no one is going to repeat in the name of Jesus by thunder, by force. Yes. Okay, so 8.1, guys, they say that differentiate f of x, which is equal to negative x into that from first principle. Remember the rule, guys. Is to what? When you hear from first principle, you don't have to think about it. Hearing for first principle, you just evaluate your function at x is equal to at the original value of x. This is the same as writing down your given function. After this, evaluate your function at x plus h. 11 minus into x plus h squared minus 3 into what x plus h. You see these two tells you now you have the square binomial. So this is x squared plus 2 x h plus h squared minus 3x minus 3h. When you distribute the negative inside, guys, this is what you have. Now distribute what? The negative inside there. You'll have negative x squared minus 2xh minus h squared minus 3x minus 3h. Therefore, this is f at x plus h. Guys, so what's the next step? The next step is to write down the first principle. So the limit as h approaches to 0 of f at x plus h minus f of x, everything divided by h cannot be 0. So now this is the limit as h approaches to 0. F at x plus h is just that part, negative x squared minus 2 h minus h squared minus 3x minus 3h minus. So we are subtracting what? Our original function, which is negative 2x minus 3x. Always, guys, protect the original function. Think about it, guys. Don't make silly mistakes here. So now, when you distribute the negative inside, you have plus x plus 3x. So this, they rationalize. Those are like terms. You don't have to group them, you just subtract since they have different sign. And then you just have the remaining part there. So now, h is common everywhere. That's the factor. Factor it out. That's what your common factor. So your h is a common factor there. You have something like this. So the numerator, denominator rationalize, you'll have the limit as h approaches to 0 of negative 2x minus h minus 3. Replace in the place of h with 0, but mentally you don't have to show any calculation. So therefore, your derivative from first principle is just negative 2x minus 3. You know, guys, that will be the answer. Oh, that will be it. So now, to the next question. Okay, so let me write this down for you to see what we have. You have the two there. It tells you have what? Square binomial. Deal with that first. I'm just going to write it here. This is x times x, and then this will be plus x times x into -1, and then plus x -1 times x, and then plus x into -1 times x into -1. You'll have x squared plus 2, and then plus x into -2. 1, 1. You have the same base, the power of the product. Add the exponent of 1 minus 1, that's 0. The number to exponent of 0 is 1, so you have 1 here. Also have 1 here, 1 plus 1, that's 2. So it means now you have the x is what? Is x squared plus 2 plus x minus 2. So now take the derivative of the inside, you put equals to, so this is 2x using the power rule. The derivative of the constant is 0. You'll have negative 2x for that part from the same exponent reduced by 1. Simplify this further, you have something like x into every for 4 marks, guys. You see, for 3 marks. Those are just 3 marks, guys. Oh, so now, guys, for 8.3, I'm just going to write it here. Or should I make a space? Okay, make a space after this one. So we have y is equals to negative 3x squared minus 3 all over that. Okay, you have the 3. You can see you have the 3 and then plus 3 minus 1. So guys, this is the same as y is equals to negative 3x squared minus 3 times x into 1 all over 3 plus negative. Let me take this. Okay, let me write it down. You have negative 3 times 1 all over what? X, the bottom part you can write this like that. Remember, when you take the reciprocal of this is the opposite of what you see, which is going to give you this part. Understand? And then this one is the same. This is the same as taking the reciprocal of this, the opposite of what you're seeing. This is what? It's not a fraction, so the opposite of what you're seeing is going to be what? A fraction. And then a positive exponent. So now you have 1 all over. You don't take this. You see someone saying, when we take the derivative, you say negative into that, and then you say into minus 2. So now taking the derivative of this using the notation that was given, it is going to be negative 6x. Okay, so this is going to give us 3 into x. So you'll have 3 all over 3. That's 1. And then let's see negative 1 over 3 minus 1 is 3 into negative 1 minus 3. So this is negative 3 all over 3. That's negative 1. Did I, have I done that correctly? Let me see. Okay, so this is 3, negative 1. And then what? And then minus 3. So this is going to give us negative 4 all over 3. And then the derivative of a constant is 0. So guys, and then from here, guys, you have to simplify this further and say this is 1 all over x into 4 and then the 3. It's like borrowing your money, you have to pay that person back. Initially, that person is what? 1. Now is what? 4. So now there is a change. So it means it helped. Yeah? So guys, let's see the next question. I'm just going to erase this part here. So you know the derivative of that one there will give us negative 2x minus 3. Yeah? So now, okay. So next question. Yeah? Next question, 8.4. 8.4. They say that okay, the tangent to the curve y is equals to this is a tangent, né? So we have y is equals to mx plus c. Oh, this is a curve, not a straight line. So the tangent is the one which is in standard form mx plus c. And this is what the curve, parabola, né? is perpendicular to the line y is equals to -2. So your tangent is perpendicular to what? So your tangent is perpendicular to this line, meaning they form a 90-degree. But now that's not gonna help us, ne? But we know that if two lines are perpendicular, the product of their gradient, it is equals to -1. And we know the gradient of this, it means we can be able to find what? The gradient of what? Of a tangent line to that curve there. So it means we can say the product of their gradient, since they are perpendicular, is equals to -1. We know the gradient of don't know the gradient of m1, but we know the gradient of this, which is -2 into -1. So m1, it is what? Half. So it means now we have y is equals to 1 all over x, that's the gradient, and then plus c. You just need the c coordinate there. C value there. So now, they were not looking for the equation. Okay. But here is the what? They were not looking for equation of this line, but they were looking for, they did say determine the x coordinate of the point of tangents, the point where the tangent touches the curve. So you have a curve, then that's that. So you need this point there, the x, but the x, only the x, ne? Only the x. So now that's very simple. Since this is a gradient of a tangent, remember, I said that the gradient of what? The gradient of the curve is the same as the gradient of what? Of the tangent at x is equals to a. So I'm just going to put a constant. Right? So always remember that they are the same at that point. So it means we're just going to do what now? Now we are going to say that let's take the derivative of this. Remember, when we take the derivative of this, is the same as finding the gradient. So y prime of x is the function of x. It is going to be what? -4x and then -1. We're going to equate this with this one. So negative, not negative, but 1 all over 2 is equals to -4x. So this is what? This part here, this one is the gradient of what? M curve. This one here is what? M tangent. So they exhibit the same as at this point, x is equal to something that we don't know. Yeah? So now, how do we work it out? We solve for x. So now, taking this to your left, you'll have 1 all over 2 plus 1. So that's the same as 3 all over 2. So you'll have 3 all over 2 into -4, and then x. Divide both sides by x. So to solve for x, so divide both sides by -4, so to solve for x. So you have what now? You have 3 all over 2 dividing by 4. That's the same as multiplying by the reciprocal 1 on 3 times that, that's that all over 8. So that's 3 all over 8. So x is what? Is 3 over 8, no? Yes, 3 over 8. Let's see. So you'll have 3 divided by 2 and then divide by 4. 3 over 8, you see? So now x is equals to what? -3 over 8, since we divide by negative. So this is the x coordinate of point of tangency where the tangent touches the curve. That's it. And I can highlight it for you so as you can see, so as to see it. Yeah. So now that's it. So now moving to the next question. So this is going to be our 8.5. We see that the functions blah blah. Okay, you have a cubic because the degree is 3. You have a parabola. The cubic, the degree is 2. They say if P is that. So now let's start with that. Before we get to that part, guys, forget about that part now. Let's start with this part. Then our P of X, they say is equals to F of X divided by G of X. So it's just the ratio of those two functions. So P of X is just the ratio of these two functions. So the numerator is your cubic, which is this, and the denominator is the parabola. So now to solve for this, guys, I'm just going to give you this formula. Always remember this formula. It states if you have a cubed minus b cubed, answer is a minus b. Ne? This is because of that negative. And then this is going to be 8 squared plus a times b. Forgetting about the negative is a b, and then plus b squared. That's what that rule. So now it tells us now that our a is what there. You can simply again you have 2 cubed minus 16 there, and you don't have the 2 there. So just divide both sides by 2. So when you divide by 2 here, you'll have 16 divided by 2. I think that's 8. Ne? That's 8. So it means now you have what? X cubed minus 8. But still, how can we write this as a cube? This is the same as 2 into 3. Ne? 2 into 3, 2 times 2 times 2 times 2 give us what? 8. So this will be the same as what? As x minus 2, x squared plus x times 2, that's going to give us 2x. And then you say 2 squared. And then you say plus 2 squared. This will give you what? This will give you a 4. So it means now you have p of x, and the numerator you'll have x minus 2 into what? Into x squared plus 2x plus 4. Always remember this one. Right? I'm just going to leave that one there. So always remember that rule there. So now everything divided by what? By x squared plus 2x plus 4. The numerator and the denominator, they're going to rationalize. So therefore, your p of x now is what? Is x minus 2. Now, let's see what. Remember, we placed the full stop. Now let's remove the full stop. You see, uh, comma, and then determine the derivative there. Okay, before we get to that part, let's determine what the derivative. So the derivative of p of x will be what? Will be just 1. No? The derivative of a constant there will be 0. So now, let's say determine the average gradient at what? At x is equals to 3. So now, the average gradient at x is equals to 3 is just 1. This will be your answer. Like that, you're done. Guys, don't forget to subscribe. Don't forget to like. Please leave a comment, a simple comment saying thank you. No? It will really help. It will really help. Guys, this is June exam from Limpopo, 2025. June exam. No? So they wrote this paper here. Let's see how hard or this question was simple. Yeah? Let's see how simple it was, how hard it was. So now, what I need you to do, or what I want you to do, is to say 21 over 150 is 100%. And let's see what you have got there. And I think you will have got something like 14%. Let's see before we dive into this. 14 to something, 13 to something. So 150 times 100. 14%, you see? So this 150 here, this is what? The total mark of what? Of paper 1. Ne? And let's say that from your question 6, you got 21 there. Now you got total here. So you see this question 6 will have give you what? 14%. Ne? It will have what? Given you what? 14%. So you'll have got 14% from this question, guys. just from this question 6. So it means now from 100% minus 14%, you have what? 86%. You're left with 86%. You're left with what? 86%. So you see, guys, how good it is to know your derivatives. This is part one of calculus. Know your derivatives well. This will get you or give you marks in the exam. So now, enough with the talking. Let's start with 6.1. Once we hear from first principle, we don't have to read the whole thing there. Once we hear from first principle, now we have to evaluate our function at the original value of what? Of x. So now let me use like that. So 6.1. So okay, the derivative of this using the basic rule would be 6x minus 2. So we have to find something like have something like this as our final answer here. So now evaluate your function at the original value of x. It's the same as writing down your not the first principle, but your given function there, and then evaluate your function at x plus h. It's the same as replacing the place of x with x plus h, keeping everything constant outside. That too tells you have the squared binomials. Before you distribute the three inside, deal with that. You'll have 2x squared 2xh plus h squared minus 2x minus 2h. When you distribute the negative 2 inside, distribute the 3 inside the, you'll have what? 3x squared plus 6x h plus, what is this? Plus 3h squared minus 2x minus 2h. This tells you now you have f at x plus h. Write down the first principle form. F prime x, it is equals to the limit as h approaches to 0 of what? Of f at x plus h minus f of x. Everything divided by h, which you cannot see. Otherwise, this whole equation is going to be undefined. So now, taking the limit as he approaches to 0, as he become extremely small. So your f at x plus he, it is just that part there. So this is the 3x squared plus 6x he. Okay, we have to check if we are recording. So, okay, 3h minus 2x minus 2h. So now you have this negative there. So it means you have to subtract what? Your original function, which is what? Protect your original function. All over what? H. We don't like wasting time. When you distribute the negative side, you'll have negative 3x squared plus 2x. This negative is positive, and the negative one there rationalize the negative, and 2x and the positive one rationalize. So now you have the limit as h approaches to 0 of the top part 6x h plus 3 h squared minus 2x and 2h. H is common everywhere. That's your factor. Limit as h approaches to 0. Factor that out. So you'll have h outside 6x plus 3h plus or minus 2h h. Top and bottom rationalize. So you'll have the limit as h approaches to 0 of what? Of the 6x plus 3 h minus 2. So now we have reached the stage where we have to replace in the place of h with 0 there. So now when you replace in the place of x h with 0, you just have the remaining part. Not the remaining part, but you just have this part there. And again, this you have just have the negative 2 there. Remember, when you distribute the h inside, you'll have negative 2h, and that's what you have. So in the place of 0, replace with what? The place of h replace with 0, so you just have those part there. Therefore, the derivative from first principle is just what? 6x minus 2. Is this the same as what you have there? Yes. So now, next question. This is not first principle from this. This is the, what is this? This is the limit concept, when you encounter or when they introduce you into calculus. This is the first concept that you will have to first deal with it. Yeah? So now you know x cannot be what? Cannot be 3. So it means we have to do something. Yeah? So now, looking at the numerator and the denominator, we have to try by all means to eliminate the what? The denominator there. By what? By the numerator. So now, to write this, this is the same as the limit as h approaches to 3 of what? This part here, you can just write it as you're solving for x in the bracket form. Yes, so you'll have 2x minus 5 into x and then minus 3. This will give you a positive 15. This will give you a negative 5x. And then this will give you what? A negative 6x. You sum these two, will give you what? A negative 2x. This one times this one will give you what? A 2x squared. So I hope you understand that. So now you have all over 3 minus x. Is it the same as that one? You cannot say 3 divided by that, 3x divided by that. Yes, you can say so, but guys, remember, you have to know what you're doing, and not just write things, or in a way that you like it anyhow. So this, you have to try by all means to make the numerator looks the same as what? The denominator there. So this is the same as 2x minus 5 into x minus 3. You can write this, remove the, or take out the common factor, or factor out the negative. You'll have what? X plus, not plus, but a negative 3. So that when you distribute back, you'll have a positive 3 and a negative x. You sum these two, you'll have negative x plus 3. That's the same as what you have there. So you can just say this is what as you have before. What you have before there. So now the numerator denominator rationalize. Now you have the limit as h approaches to 3 of what? Of 2x minus 5 all over negative 1. So now we have to replace in the place of what? And then this is supposed to, it's not supposed to be h, guys. They made a mistake here. This is x approaching to 3. Let me fix that. X approaching to 3 because there is no h here. Where are we supposed to substitute 3 in the place of h? They made a mistake here. I believe they told you, you people from Lipo, that there was an error here. So what you have wrote there is to say x is just approaching to 3. You see why I'm saying it's very important to know what you're doing, guys. Now someone will below say, where is h approaching to 3 now? You see, there'll be a trouble. So now this is x approaching to 3. In the place of x, replace with 3. Drop the limit, say is equals to 2 into 3 minus 5 divided by negative 1. So now you'll have what? 6 minus 5 all over negative 1. This is what? 1 all over negative 1 to give us a negative 1. That's our answer. So now the next section, 6.2.2. Okay, let me just write it here for now, and then after this, we'll have to make a space. We're given g of x, which is equals to x into 4 minus 4 all over x. Can we take the derivative directly? No. The one independent variable is what? At the denominator there. So this is g of x is equals to x into 4 minus 4 into x minus 1. Take the derivative of this. Left 4x into 3 plus 4x minus 2. This is 4x into 3. I'm using the power rule. So our final answer is this one. It's like borrowing money from someone. You see, you have to pay that person back. How do you pay him? After seeing that he helped me, you have to pay that person back. So you see, that person has to profit. Now, before that person was having 1, now you have what? 2. So there is what? An increase in that. You see? So now, guys, I have to make a space for 6.2. I have to erase this part. You want me to do that? Okay, yes. Okay, so moving to the next question, 2.3. We are given y is equals to x plus 3, and then 3 minus x. Can we take the derivative directly? No. It's like having x minus 1 squared. Next, we cannot take the derivative directly. So we have to deal with this. So this times that will give us 3x. This times that will give us negative 3x. And then this times this will give us plus 9. This times this will give us negative 3x. So remember, this times this has to give us not negative 3x squared, but negative x squared. And then this times this will give you 9 to that. So now y is equals to what? Is equals to, let's write this in the standard form, negative x squared. The 3x minus the 3x there, they are going to rationalize. So these and these ones are going to rationalize. So left plus, what is that? Plus 9. Ne? So guys, this is x squared. And then you left to say what? 3x minus 3x. This rationalize, you have what? Plus 9. There. Understand? Yes. So now taking the derivative of this using the notation that we were given, I think that's the same. So now this is just negative. This will be the derivative. For 3 marks, the first mark should come from what? From writing what you have, or from multiplying there inside, or distributing, what is this? The multiplication and stuff. And then the correct mark, the next mark will come from here, and from taking the derivative of constant, saying it's 0 there, but you don't have to write it, it will give you a mark. This will be 3 for that. You understand? Okay, make sure that you understand this case. So now we have dx, which is 3 into x minus 4 all over x. This is the same, not is equals to, we cannot take the derivative directly, so this is the same as 3x into a half all over x into half. So this and this eventually goes away. And then you left that into 1 all over 2. So now you have dx into 3 minus 4 times x into negative a half. You know by now, guys. You left 4 times 1 over x. Take the reciprocal of this there inside the bracket is the opposite of what you're seeing. So it's just that part there. So now, derivative of the inside, the derivative of this is 0. And then the derivative of this is positive 2x. And then negative 1 over 2 minus 1. You have 2 minus 1 minus 2. This will give you negative 3 over 2. Are you done? Nope. So this is 2 all over the square root of x into 3. This is your final answer. So now, just going to make a space and where maybe. So I'm just going to erase this part. And remember, the limit from that will give us negative 1. I'm just going to write this here. Just going to squeeze it here. So for 6.3, guys, I'm just going to squeeze it here. Determine the equation of a tangent to your function at x is equals to that. How do we find the equation of a tangent? These guys, I'm always going to make a picture, or picture this for you. So now, since the value of a is greater than 0, then the degree is 2, meaning this is a square, a parabola, a quadratic function. So you have a smiling graph. You have a tangent at negative 2. What do you know from what I told you? I told you that the gradient of what? Of the curve and the gradient of a straight line, they're what? They're exactly the same at what? At x is equals to negative 2, since they gave you that point. If they didn't give you that point, it would be at x equals to a. Understand? So it means now we have to take the derivative of what? Of this gradient. So now, when we not the derivative of the gradient, but the derivative of what? Of the curve, this is going to be what? 2x minus 2. then the derivative of that, using the power rule, guys, you have something like this. You understand? Always you take the derivative of this, you reduce by 1, multiply it there, and then reduce by 1, derivative of constant is 0. So you have something like this. So now, this tells you now this is the gradient of what? Of the curve. And it has to be exactly the same as what? The gradient of what? Of this tangent. At what? At point x is equal to 2. So now, let's find that gradient at x is equal to these two there. So let's see what is the gradient at x is equal to 2. I believe by now you understand what we are doing, guys, in calculus. Né? So this is about the gradient, concavity, so on. Né? So now, without wasting time, this will give us this will give you not 2, but a negative 8, negative 6. Let me see. 4 times negative 2. This will give you a 2 times negative 2. That will give you a negative 4 minus 2. That's what? That's 6. Ne? 4, 5, 6. Negative 6. So therefore, your y is going to be what? A negative 6x plus c. To find this c for this tangent. Now, this is the equation of the tangent. Why is it the same as the equation of the curve? Because we know that once where the tangency happens, they have what? The equal gradient there. Yeah? The curve and the tangent. So now, to find this c coordinate is very simple, guys. You're not just going to say this is 3. They didn't tell you that it cuts at the y-intercept of the curve. So it means you're going to say that where to my original function, remember this x minus 2 is also a point. So I'm going to say, okay, if x is equal to negative 2, what is y to original function? So this is going to be f at negative 2, and then negative 2 squared, negative 2 plus 3. Let's see what is that. So this is what? Negative 2 squared minus 2 minus 2 plus 3. 11. So you see, y is 11. No? Y is what? Is 11. So c is not 11. So this tells you now the point is what? Is negative 2 and 11, where the tangent to the curve happens. No? So how are we going to deal with this? I'm just going to move this here. No? So should I make a space somewhere else? Okay, guys, you'll understand. I'm just going to take this here. No? So what you do is to say now you have what? Y, which is equal to negative 6x plus what? Plus c. To find c, you just have to use those points. So 11 in the place of, remember this is xy. So this is negative 6 into negative 2 plus c. So that's 12. And then that's 12. This will give you 12. And then 11 minus that 12 is going to give you c. So 11 minus 12, that's negative what? 1. Understand? That's negative 1. So now, let me see if I did that correct. Negative 2x squared, then minus 2, and then plus 3, yes. And then it gave us what? 11. And then now, you say what? Negative 6 times what? Negative 6 times, what is this? Negative 6 times 2 is going to give you what? A positive 12. When you move it to your left, it's going to become what? A negative. Now, 11 minus 12, that's what? A negative 1. So you see now is what? Is negative 1. So therefore, the equation of this tangent line, it is what? Negative. Let me write this nice. It is negative, not negative. Y is equal to negative 6x minus 1. That's it. I hope you understand this. Are there any mistakes or errors that we made so far? No. We have to confirm them. This to that gave us negative 4 minus 2 to 6. Negative 6. And then what to find c, we take that to that, and then 11 to that, and then to that to that. Okay, so that's it. Use that. So now to the next question, guys. Remember, this is 14%. That was so simple, guys. So now, this is also the trial question paper from Limpopo again, but not 2025. I forgot what year. Or I forgot what year. And so now, guys, do I have to like do it for you this one? Okay, I'm just going to be fast, eh? So evaluate your function at original value x same as start, then evaluate your function at x plus 3, at x plus h, I mean. So this is the same as 3x squared plus 6x h. Yeah, when we do it on my own, guys, this is going to be different, eh? Because me now I don't like wasting time. Yes, serious, I don't like wasting time. So by now you understand what's really happening here. Just writing for the sake of sorry. So this is the limit as h approaches to 0 of what of 3x squared plus 6x h plus 3 h squared minus 3x squared. So I don't like wasting time. I know this and this rational limit. So the limit, okay, so when you know what you're doing, you don't worry about protecting. If you know what you're doing, you don't worry about what protecting. Okay, hope that sinks. So now I have this. So now this is rationalized. So therefore, f prime of x is just 6x. See how fast I am. Lightning. So now, next question. This one I'm going to explain for you guys. So, okay, you have to know what's really happening here. They say now determine what the derivative if you're given that. So, guys, let me show you what's really happening here. Distribute the x first. You'll have what x into 7, x into 6, x to 5. You have the same base. I'm using the product of the power method. X into 4, x into 3, x into 2, x. Negative x into 6, negative x into 5, negative x into 4, negative x into 3, negative x into 2, negative x, negative 1. So what? So now, what does this tells you? It tells you now the negative 6x and the positive x, they're going to rationalize this. Where's that one? This is the 3, this. So therefore, this is 7.2, 7.2.1. Okay. Since I'm answering here, so it means now our f of x for this part, it is just what? It is just x into 7 minus 1. Then taking the derivative of this, it is what? 7x to the 6. That would be your answer. That's it, guys. I'm fast, but I explain what's happening there. If you can go again and watch again the lesson, review again until you understand what's really happening. I said first, deal with the x. The x is what? Okay, let me see. The x is what you have as a numerator. What you have at the top there. The negative 1 is what you have what at the denominator or at the bottom there. So on. And then when you group all of those ones there, all of them, when you group them, some of the terms they're going to rationalize. And then you left the remaining part. So now, enough with the talking. This is 7.2. Okay, let me just write it here. The 7.2.2, you're given the is x cubed plus 2x squared plus x all over x plus 1. Remember, this is a trial question paper, né? So now look what's really happening. X becomes what? Your factor in the numerator there. X becomes what? Your common factor. So now factor that out, you left the parabola now, which is 2x plus 1, and then x plus 1. So remember, guys, that the goal, I should have stated that x cannot be equals to -1, meaning that we have to try by all means to eliminate the what? The denominator by the numerator there. So now you have what? X into x plus 1, x plus 1 again, then over x plus 1. When you deal with that, this part from x going to the right, you have something like that. So this part and this part, you just choose which one you want to get rid of. So now I'm just left with this one. You know we don't like wasting time. Simultaneously distribute the x inside, you have what? X squared plus x. Derivative of the inside is 2x plus 1. And this will be answer. So now 7.2.3, we are given y, which is equals to x into that minus 1 over 3x. This is the same as what? We cannot take the derivative directly, guys. I don't have to say this again. You know what we're doing. Next. So now this is x into 1 all over 3. Unless now you're in varsity level, guys. Here you'll have to use what is this? We have this rule that we have, we don't have this rule that say we can take the derivative of this. You cannot take the derivative of this. Also in varsity level, guys, you'll have to write this as x into a third. No? Only here you can take the derivative of this using the quotient rule. No? Squaring the denominator and then taking the derivative of the numerator, and then keeping the original function of the denominator, subtract your numerator, take the derivative of the denominator, so on and so on. That's the quotient rule. But in this case, guys, we have to stick to your rules. So now, taking the derivative of this, you'll have 1 all over 3 x. Let me see, 1 over 3 minus 1. I'll have 3 into 1 minus 3. This is -2. So you have -2 all over 3. Then what is that? Plus 1 all over 3 x minus 2. This will give us 1 over 3 times 1 over x. Okay, let me just turn it into a square root, x squared, and then the 3 plus 1 over 3, then x squared. That. So now you'll have 1 all over 3 x squared, and then the 3, then plus 1 all over 3 x squared. So now let me confirm that one. 1 all over 3 minus 1, 3, 1 minus that. Okay, that's it. So now this is the what? Derivative y with respect to x. Next question. We are so close, guys. We are so close. You can see only the trick questions here, guys. The trick ones. Don't forget to subscribe, né? For more lessons. So now, do I have to take the derivative here, guys? Okay. No. I'm not going to explain, but you're just going to see what I'm doing. Taking the derivative of what? Not the derivative, but evaluated the original value of x. That, and then x plus h. So now I will have, let me just deal with this first. So the limit as h approaches to 0, f x plus h minus f of x. So substitution now. See, guys, if you know what you're doing, you don't have to protect. Mentally, I dealt with the negative. So now h is common at the numerator, then that's your fact. Is this rationalize? Now you can take the limit. Where there's zeros mentally, place what? Where there's h, place 0 mentally. So final derivative is this. Like that. So now determine the gradient of a tangent to where or to f where x is that. So this is simply this. Just make the substitution where there is x name into your gradient formula. So you'll have -1, this will give you a +2. And that's it. And then here, remember from first principle, we got -2x. So I'm writing this so that whenever I raise these guys, so that you can see what was the derivative there. So now, enough with the talking. 8.2, we have something like this. Can we take the derivative directly? The answer is no. So 8.2.1 f of x be -3x cubed minus 2x into we actually know what we are doing. Take the derivative here. You have -9x2. So what is that? X to -12, then -9x. So all over this way. This is your answer. So now this is called whenever you see x and y on the same place, guys, or in the same place. That's called the implicit differential, meaning that you have to what? You have to make y the subject of the formula. How do you make y the subject of the formula? You are going to do what? You are going to divide both sides by what? By x to make y the subject of the formula. So 8.2.2 dividing, okay, before dividing, and see we have something here. So now this is the same as xy is equals to x squared. Guys, if you don't understand what I'm doing here, please try to your own and see if you get the same answer, because now I know what's happening here. So I have -2 then plus x to -4. Someone will be like, what's happening, man? We have x and it's x, and then we have minus x minus 2 times x, and then times this by 2, and then you'll have x minus 2 times x minus 2, and then this, remember here you have what? You have the, okay, see what's happening now. This will give us a negative x into -1, because you'll have what? You'll have negative x into a -1. You have the same base after the exponent, you'll have what? 2 minus 1, that's -1. Multiply this by 2, you have that. Understand? So now, this is a -1. So now, divide both sides by x, where you can have, or take the derivative with respect to x. So now you have y, which is equals to x. You have -1 minus, not minus, so I will give you -2. So this is -2x minus 2. You have -4 minus 1 equal -5. So this is plus x into -5. Derivative of y with respect to x1 plus 4x minus 3 minus 5x minus 6. 1 plus 4 over x into 3 is 5 all over x into 6. Therefore, this is your derivative of y with respect to x. We are done. Do you want us to confirm? Okay. So now, dealing with that part there, you say x times x. This x times that give you what? X squared. And say this x times that. Remember, you take the reciprocal of this is the opposite of what you're seeing. So it's going to be what? Plus x times x into -2. And then There will be the same of this, net the two of these, so you just double it because it's still the same thing to that, you see. And then you'll have this remaining part, the negative x2 times the x into the negative 2. Then here you'll have what is this? Let me see. This times that, and this term is this. Then you have that. So okay, you see you have the negative here. So it means now you're going to have what? Oh, how am I gonna deal with this? Okay, let me see. You have plus x times x into negative 2. Oh, I see what's happening now. So this part here will give us negative x into what? Into negative 1 plus x into negative 1. So now eventually this will what? Will go away because I'm using the product of the power. You have the same exponent at the exponent. You have the same base at the exponent 1 minus so 2 will give you that, and this and this and this rationalize. So now you just have what? You just have x squared and then minus x into negative 4. So now this tells to say now this is what. See how it is good to always confirm this. I don't want to give you wrong information. That's not my aim. So this is x squared. So you still have x. And then minus what? X into negative 4. That x minus 2, that means x minus 2. Remember, you have the negative from this one. You have the same base, keep the negative outside, take the exponent negative 4. So build it back, you have that. So now, taking the derivative of this before that, divide both sides by x, left that to y is equals to what? This is 8.2.2. Left y is equals to x, then minus x into negative 5. Left minus 4 minus 1, always using quotient of powers. You have the same base, subtract the exponent, you see the top one minus the bottom one. You have the invisible one there. So taking the derivative of y with respect to x is just 1 plus 5x 6. So this is 1 plus 5 all over 6. So derivative of y with respect to x. I don't want to give you wrong connection, guys. And if you saw an error that I made, please fix that. Ne? So now, guys, moving to the next question. I'm just going to erase this part. Ne? This part. I'm just going to erase what this part there. Okay, I did. So seems like I made an error again here. So remember, you have something like this. When you take the derivative, you have that. So it means now you have the 2 here. Understand? And then the derivative of this, give us what? You'll have negative 2 times 1 all over 2. The 2 and the 2 rationalize, you have negative 1. So that's correct there. Then minus 1. Then I write this as that. So now this is it, man. Sorry for that. Again, if you saw error somewhere, please, I hope you will fix that. Man. So now 8.3.1. So guys, they say that we are given the function h of x, which is equals to that. You have a straight line, you have a hyperbola, so on. So now they say determine the equation of okay, the derivative of h in terms of k. They know that now the reason why they said in terms of k, they're telling us, okay, now let's pretend k is some constant value there. Understand? So now before h you have something like this. And the k, we cannot take the derivative directly here. So yes, so say k is a constant and then 1 all over x, which will give you a k times x into negative 1. This is h of x. So taking the derivative of that give you negative k x negative 2 Then when you replace that back or take it back, you'll have something like that. So therefore, H prime x is that. So now 8.3.2, they say that calculate the value of k if it is given that g is a tangent to x. So you remember g, it is 3x plus c. This is mx plus c. Ne? It is what? A straight line. Also what? A tangent. To what? To your h. So now, this tells you now about what I told you. Ne? About what I told you. So now, the gradient of h and the gradient of a straight line, they're going to be what? The same. So you're just going to say, okay, my negative k all over x squared is just going to be what? 3x. And then to make k the subject of the formula cross multiplication, you have 3x cubed. So k eventually becomes that when you multiply by the negative there. So I can call this equation 1. How do we find equation 2? We know that where they intersect, the h and the g, they're what? They're the same. The what? The y value and the y value at g, they're what? They're the same. The y value is just that part, and the y value here is just that part. So it means now k all over x is what? Is the same as 3x plus 6. And then this is the same as cross multiplication there. This is going to give you 3x squared plus 6x is equals to k. What is k? K, we know that k, it is negative 3x cubed. Yeah? Negative 3x cubed. So it means now we are going to do what? To take this to the left. So now this is going to be negative 3x cubed plus 3x squared plus 6x is equals to 0. So now, how are we going to deal with this? We are going to say that did I make this? Okay, I think this is correct. So now we can simply take out x as our common factor. So we left negative into that, and then okay, but divide both sides by 3. So you'll have negative x cubed plus x squared plus 2x is equals to 0. And then take out x as a common factor and have something like this plus x plus 2 is equals to 0. So x is equals to 0. Or you can multiply both sides by negative there. Before this, you can multiply both sides by what is this? By a negative. It means now this becomes positive, and then this becomes negative, and then this becomes negative. And then to solve this, you have what is this? Okay, before equating to that, let's solve this. You'll have what is this? You'll have x minus 1, x plus 2. Okay, let me say plus and then negative 2 there. So when you distribute this, you have x squared negative 2x to that, you give you that. So now x is equals to 1. X is equals to 0, x is equals to negative 1, x is equals to negative 2. Wow. X is a lot. Now x is a lot. So now guys, which one is x? Which one is x? Which one is going to be the x there that we are going to use? Because it seems like k now it is going to be k cannot be 0. K when you substitute there, we're going to have different k values. So now, okay, I just want to confirm something. Yeah, I saw the mistake, guys. This wouldn't be possible for us to have x is equals to that. See what's happening here. And I'm sorry for that. For us to go through this, knowing that unknowingly that we are making a mistake. Remember, I said that the gradient of h has to be the gradient is exhibited as gradient of what? Of the tangent. Yeah? So remember, I took the gradient of the tangent with the x. Remember, this is the gradient. We are not including what the x. So this is k has to be what? K has to be equals to that. So now to solve for k will be x is equals to what? Negative 3x squared. So now I shouldn't have erased that. So but okay, let's go to that again. So this is equation one. So I'm just going to equate this with that. I explain the reason is that where there is tangency, those the y values of those two functions are what are the same. So remember, k is what is negative 3x squared. Why negative? Remember, it should be negative and then here positive. Then you have to multiply both sides by negative. Né? So now this is that into 3x plus 6. Cross multiplication, you have 3x squared plus 6x is equal to negative 3x squared. So now taking this to that, you have plus 3x give you 6x squared plus 6x is equal to 0. And then divide both sides by 6, x squared plus x is equal to 0. So for x is equal to x and then plus 1. Then x is equal to 0 or x is equal to negative 1. X cannot be equal to 0 there, guys. Yeah. Once remember, if we have 0 there, it means now h of x is just what is 0. So this cannot consider that one. So now substituting this x is equal to 1 to the k there, k now becomes what? This will give us a positive value, so k is equal to negative 3. Yeah? Since 2 is an even number, you'll have a positive 1, and then negative 3 times 1 is negative 3. So your k here is just negative 3. You are done. Sorry for that, guys. Nah? So, okay, to the next question. Should I have to go through this? No, I'm not. To prove to yourself that you understood what I was explaining, guys. Sure. That what I told you understand. So go through this alone. And you should find that the derivative here should be what? Should be 6x minus 2. I'm just going to only go through you. If I found that there is this, what let's say now, okay, what I mean is that, guys, I will only take the derivative from first principle if the function that we're given seems to be challenging. Understand? Okay. So now we are taking the derivative of what? Of y with respect to x. So it means now we have to treat the expression that we have here as what? Or the other terms is what is a constant. So your 4b there has to be what? A constant. So that's the meaning of take the derivative of y with respect to what? To x there. So your x becomes your independent variable there. Yeah? So x becomes the independent variable. So 8.2.1. So go through this alone, guys. Please go through this alone. So now, taking the derivative, can we take the derivative directly? That says no. So you have 1. I can write this as 1 all over 2x to the power minus 5. You know what's happening there. So and then plus 4b into 3. So now taking the derivative of y with respect to x, meaning we treat other terms, not x, but other terms as a constant. So now you'll have negative 5 all over 2x into a negative 6. You'll have minus 1, you'll have negative 6. Then here you'll have a negative 7. This eventually becomes a constant. So now, therefore, the derivative of y with respect to x, it is just negative 5 all over 6, not over 6, but 5x into 6 minus 7. So now, question 8, again, even this one, guys. This one, you are going to do it on your own. You have to find that the derivative of this is just 8x minus 1. So take this using the first principle formula. If you find the same thing, drop the comment. Eh? Drop what you comment and say yes. Or simply say thank you. Eh? So now guys, to 8.2.1, you have the x. I'm not going to waste time here, so I'm just going to provide what is right. Taking the reciprocal of that's the opposite of what we are seeing, so that's half into that. So taking the derivative of this side, we'll have 2x, what is this? Plus 3 all over 2, x minus 4, plus half, x minus half. So now this is 2x plus 3 all over 2, x to the 4, and then plus half, m is 1 all over square root of x. So yeah, just going to leave it like that, or you can say, okay, this is just the 2, and is that the 2 there, then the 1 there. And of course, you have that plus sign. Understand? Okay. So now, again, we are taking the derivative of k, or derivative of y, not k, the derivative of y with respect to what? To k. Meaning we have to treat the p as what? As a constant. So now, you are given what? You have 8.2.2, you have y. So this is a square binomial. The tool tells you now you have a square binomial, so that's k squared into, let's see, k times that will give you k times that will give you that, and then I see minus 4kp, then plus what is this, 2p, and then we have the square, 2p squared. Eh? So this is what I mean, guys. You'll have k minus 2p, k minus 2p. This times this will give you k squared. This time this will give you what? Give you minus 2kp, and then times this by 2, get you minus 4kp. This times this will give you minus, okay, this times this will give you a positive 4 into 4p squared. Ne? So now, taking the derivative of y with respect to k, meaning we have to treat other terms as a constant. So you'll have 2k what? 2k, and then minus 4 into, okay, I should have wrote this as 4pk. So when we take the derivative of this, we're going to say, and then reduce by 1 there. It means now this becomes 1. So you have the 4p. The derivative of this becomes 0. So your answer is just this part. Understand? It's just this part there. That would be it. So now, let me use leg. So now they say that the function f of x and j have a common tangent. So they have what? Same tangent. So guys, whenever you hear that two halves have a common tangent, what you have to think of is that their gradient is what? So please write this down. Their gradient, the gradient of f of x at let's say now I don't want to focus at x is equals to 2 because this point will keep on changing. So I'm just going to say at x is equals to a. So at a, the gradient of this part there, f of x, and the gradient of g of at x is equals to a, they are the same. And again, the value of f of x is the same as the what? The value of what? Of g of x. Only at that point, guys. What I'm saying, the reason why I replace with a, I'm saying at that point, they're the same. Understand? So now this can give us what? Two equations. Since we just have one unknown, it means we don't need the other part. Either choose to use this or either use to choose this. I'm just going to show you both of them that they're pretty gonna work out. So now this is 8.3. Let's use the first one. Let's use what? The first one. right? So now let's use the first one. Yeah? So using the first one, I'm just going to take the derivative of the both function. So I will have what? Negative. Okay, let me show you which one I'm taking the derivative of. So this is negative 2x, and then the derivative of g of x, it is going to be p, it is going to be negative p, and then x into negative 2. Not negative, yes, negative 2. Remember, you left p times 1 over x. The reciprocal of this, the opposite of what you're seeing. After taking the derivative, you have that, and negative 2x is equal to negative p x into that. They are the same way. At a, x is equal to a. You a now, a can be what? Okay, let me say a is a constant. Also write this down. This will help you, trust me. So your a now is 2. So this happens at what? At 2. So you can say 2 into p, then 2, that. This will give you negative 4. And then this will give you negative into 4. And then cross multiplication, now your negative p is just the negative 16. P is just 16. That's the first one. Or use what? The second one. So I'm just going to say this first one, second one. So now the second one there, remember we're done, but I'm just going to show you the second one. The second one is to see what? To equate their two functions. So negative 3x squared, they are what? They have what? The same, let me just say, same gradient, same y value, so that you understand what I am saying there. So now plus 9, remember y value, guys, this is the same as y, this is the same as y. So they have the same y value there. So equate those two y values. So this is the same as p all over x minus 3. This happens when at x is equals to a. A is a constant, and then x is equals to 2. This 2 is a constant. So now you are given that 2. So simply make the substitution. This will give you negative 4 plus that will give you I think that's 5. Is it 5? So you have minus 4 plus what is this? H. You have minus 4, guys, plus 9, and then 4 plus 9 will give you what? Just 3, ne? So is it 3? Yeah. Is it 3? No, it is 5. Ne? It is 5. So this will give you 5, guys. I was correct. I don't know what's happening now. 5 into p over 2, and then minus 3. Take this to your left. You have hey, left 8 into p. So you see, when you do the cross multiplication, p is it? Isn't it, you guys? Isn't it 16? Yes, no? So now it is 16 there. Yeah. So you see, choose which one will be best there for you. And we're just going to be wrapping up now, guys. You see, just 3 questions left. Should I do it on for you guys? No. This one you have to do it on your own. Ne? So now the derivative of this will be just the 3x squared. So okay, I think I have to show this one because now we have the cube. Okay, let me show it. First, evaluate the function at the original value of x. So this is going to be x cubed. Then evaluate your function at x plus h. So you'll have something like x plus h and then cube. You see now, this is a trinomial, right? Trinomial, not binomial. This is trinomial. So this is the same as say x plus h and then x plus h and then squared. You have the 1. You sum the 2, you have. So now it means you have x plus h and then deal with the square binomial there, the 2, you have x squared plus 2x h plus h squared. To be the h first, you have h cubed plus 2x squared, the h plus h, and then that, and then now deal with the h part, you have x squared h plus 2x h squared plus HEQ. Look for like terms. This part here, it is the same as this part, and this part is the same as that part. So now this is x cubed plus 3x squared h. This one and that one give you 3, and this one plus that one give you 3. So you have 3x h cubed plus h squared plus h cubed. So therefore, this is f at x plus h. But it wasn't that hard, guys. After this, you are fine. So f prime of x is just the limit as h approaches to 0 of f at x plus h minus f of x, everything but h, make the substitution. So now this is what the limit as h approaches to 0. Make the substitution there. The f at x plus h is just the part. So 3x squared h plus 3x squared plus h cubed minus the original function, which is that. So now this part and this part rationalize. F the limit as h approaches to 0. So by now you should have already know that, okay, after this step, everything is in terms of h there. You can see you have the h. Eh? H and what? And x. So that's how you that's when you know that, yep, I've done it correct. So h becomes what? Vector there, since it is everywhere. So h is your common factor. You have 3x squared plus 3x h plus, okay, h squared. Everything to that, h will be top and bottom. Visualize your limit as h is to 0 of 3x squared into 3x h plus h squared. These ones here, they are going to go away since you are replacing 0. So therefore, derivative from first principle, it is just 3x squared. Isn't it? Anyway, guys, you see you have, okay, let me see. You see, when you use the product of the power, you'll have 3x squared. That's it, guys. Okay. This one is just straightforward, guys. The derivative of this, it is just 4x plus 2x to the 3. Using the power rule, right? This one is straightforward. This one is at the numerator there. It's not the denominator, right? So it is straightforward. For 4 into out, that's 2. And then the derivative of the constant is 0. So now, let's take a look at this one. Let me see if I use another. So now, for 8.3, guys, they say now, if y is that, prove that the derivative of y, which is your independent variable, which is your dependent variable with respect to x, will give you this. Ne? So we are required to prove this here on our left or right. Yes. So now deal with this. Okay, first let me explain why they say x has to be greater than 1. The reason why they say x has to be greater than 1, just imagine if x is less than 1, meaning you should have like 0. So ne? So when you place 0 in the place of x, now your derivative becomes what? 0. And that would be what? And that would be what? It means now the slope is what? Is 0 there. So you see, so they're avoiding that. So x has to be greater than 1 for us to have the gradient there. So now, so this is why. So now the two tells you have a square binomial. This is the same as x into 12, and then minus 2x into 6, and then plus 1. Make sure that you understand what I've done there. So this is x into 6 times x into 6 plus x into 6 times negative 1, and then negative 1 into x into 6, and then negative 1 times negative 1. This will give you x into 12 using the power of the product. And then this 2 will give you x into 6 minus x 6, the two of these. That's why I always say, when you by having 1, you can simply double it, right? So this is what you have. So taking the derivative of this with respect to x, you'll have what? 12 you have 12x into 11 minus 12x into 5. The derivative of this is 0 now. So now this is our derivative. Are we so close to proving that? Yes. So they simply took out the common factor then, which is what uh, is what the 12 into x to the 5. We have x into the 6. 5 plus 6 is what is 11. Since you have the same base, which is the x, use the power of the product. So now you have minus 1, so that you can redistribute back, you can have that. So now you have something like this. But are we so close to finding that this? Yes, we got this part, but what about this part here? What about that part there? That's very simple, guys. What they did is that from our original function, let me show you what's from our original function. Our original function is y. Okay, let's say but, ne? So that this makes sense. But y is what is equals to x into 6 minus 1 squared. So now, if we can take the square root both sides there, the 2 and the square root or the radical sign, they're going to rationalize each other. So therefore, this tells you now the x to the power 6 minus 1 is the same as what the square root of y. So now we are here. No? So this part here is what is the square root of y. Understand? It is what? The square root of y. So you're going to say what? You're going to say now, okay, therefore, the derivative of y with respect to x, it is just what? The 12 x to the 5, and then what? And then multiply by, okay, let me just say, times the square root of y. And you can say x is to be greater than 1. You are, even if you don't say x is equal to greater, x is to be greater than that. Again, they told us if x is greater than what, that's their condition, not ours. So now, guys, to the next question. What did I say about concavity, guys? I said every time you hear about a function being concave, doesn't matter concave where, but if you hear that a function is concave, think about what? Think about the second derivative. Think about what? The second derivative is equal to 0. That's all about what? Concavity. Allow me to erase this part so that I can make space. So I'm just going to, we don't need like much space here, just from the statement going down. That will be fine, whilst to deal with this question here. So I'm just going to cut it here. So let me cut it there. So now we are given a function, I'm answering 8.4. We are given a function f of x, which is equal to what? 2x to the cube minus 2x squared plus 4x. And you can tell that the degree there is 3, telling you this is a cubic function. And the value of a is what? The value of a is greater than 0, meaning that you'll have a function that starts by increasing and then decrease and then increase. Concavity happens where? Concavity is where your graph is either what? Is where your graph is either concave down like that, or concave up. And this is where this point here is what? The second derivative. Is the second derivative. So you're just going to say, okay, let's take the first derivative. It's all about what? The maximum and the minimum. It's all about the turning point. So now, when you take the first derivative, you'll have what? 6x squared minus 4x plus 4. Second derivative is all about concavity, and you'll have 12x minus 4. Equate this to 0. Why are we equating to 0? So that we can find this x value of a point of inflection. We're not worrying about the y value there. We're worrying about what? The x value. Because it is the x value that is going to give us where is, remember, when you have an x-axis that this is an x-axis, this is going to tell you where is the graph concave up. where is this starting to happen when we look vertically like that? Ne? So we equate to 0 to solve for x to see what value is that. To solve for x, take 4 to your left. You left something like that. Divide both sides by 12. 4 goes into itself once to 4 3 times. So you have like that. X is equals to 3. So this point here is x is equals to 3. That's where the concavity happens. Ne? That's where your graph is either concave down and then concave up. Now let's go back to the question. They say f concave up. This is your f. Ne? So where is f concave up? Where is this starting to happen? This starts to happen when we are reading the graph. Remember, we read graph from left to what? The right. To what? To the infinity there. So it means now our function start to cave up when we are going to what? To the right. When we are heading to what? To infinity. When we are coming to what? To negative infinity, to what? To positive infinity there. So it means now we are going to say now therefore x has to be greater than 1 all over 3. It's going to heading to those numbers greater than this number here. Think of 9, think of 20, think of 1 million. Those numbers are greater than this number. So now this is where your graph will be what? Caving up. So since they said the interval, you can also see that this is therefore x is an element not including, but from 1 all over 3 to what? To positive infinity. When you include, you're saying, okay, even when your function is just 0 there, remember the slope is just 0 there. So we're not looking at when this is just 0, but when this is what? Greater than that number there. Just two more questions to go, guys. This one I'm not going to do it. So remember, when you take the derivative here, you're just going to have 2x minus 3. And I'm just going to help you with this one. In the meantime, just think of this one. Hey, how am I going to deal with that? So I'm just going to jump straight to 8.2 and 8.2.1. And then let me use this one. So now you have y, which is equals to that. This 2 tells you about what? The binomial. So this means you have x into 4, and then you have x squared times x into negative 2 there, and then you'll do what? You'll multiply this by 2. Now, let me check something, guys. Just wanna check something here. I just wanna check something here. So okay, guys. If you spot errors, if you spot errors somewhere, don't be afraid to fix them. Don't be afraid to fix them, because sometimes it happens that I don't see that I made an error there, but me not knowingly I think I wrote it correct, because it's all about what I'm saying, not what I'm writing. I can be distracted by writing, so always jot down what I'm saying. So now you'll have something like this, and then you'll have minus 2. Okay, let me just, I think I have to write this down for you. You have x squared times negative x into negative 2. And then you'll have what? Plus negative x squared times x into 2. So this one here, you have the same base, subtract the exponent, that's going to give you what? 0. Plus into negative what? X into what? 0. This is what? Negative 1. This is what? Negative 1. So you'll have what now? Negative 2. You have negative 2, and then plus what here? X into negative 4. So now, taking the derivative of y with respect to x, yes, you have what now? You have 4 x into 3, and then minus 4 into x into minus 5, and then you have 4x cubed minus 4 all over x into 5. This will be your derivative. So this one here, this is the same as a cubed, the one I told you. Do I have to write it again, guys? Okay, for the sake of learning, now this is going to be a minus b squared plus ab plus b squared. So now this is this now is s cubed minus, remember, 1 cubed same as 1 there. So this would be x minus 1, x squared, then plus x times 1 is x, then 1 squared is just 1. So now you have the dx there, and write this as x minus 1 into x squared plus x plus 1, and then x minus 1. The top and the bottom, you rationalize it. You have what? Not this equals to, guys, be careful. Dx is just x squared plus x plus 1. The two of this side is 2x plus 1. So now let me see. I didn't left anything. Okay. So now, guys, this one here, whenever you hear about first principle formula, you know the rule, eh? You're just going to say, let's evaluate our function at the ordinary value of what? Of x. It's the same as writing down your given function and then evaluate your function at x plus h. This will be the same as 4 all over x plus h. And then write down the first principle formula. This is the limit as h approaches to 0 of what? Of f at x plus h minus f of x, everything divided by. Remember that h cannot be 0. So now we just have to make the substitution. This is the limit as h approaches to 0. Your f at x plus h, it is 4 all over x plus h minus the original function 4 all over x, then everything divided by h. You have the invisible one there. So you can now your h is what at the numerator, your 1 is what at the denominator. So now it means now your 1 becomes what the denominator, h becomes what the 1 becomes the numerator. Let me show you. The limit is going to be h as approaches to 0. So now this is the same as taking the reciprocal of this thing here. It's the opposite of what we're seeing. So it means you have to write this as a fraction. It's going to be 1 all over h multiplied by what? By 4 all over x plus h minus 4 over x. For us to have a common denominator here, what are we going to do? In maths, we cheat like this. Now, I'm just going to show you the cheat code. You have to make or at the end of the day end up having the same denominator. How are you going to do so? We have to have a common denominator now. Yeah? So how are we going to do so? We have x plus h, we have x. So in order for those denominator to be the same, means this part we have to multiply by what? By x plus h. What you do on the denominator or at the bottom, you have to do it also at the top. So now it means you have x and then x plus h. What about this part? You just have x plus h. So in order for those to be the same, it means now you have to multiply by what? By x, top and bottom. So now you still have 1 all over, okay, so you have 1 all over h there. Then multiply it with what? H. You have h, you have the common denominator. Don't split, don't distribute the x inside. Keep it as it is. So you have something like this now. You have the common denominator. Now. So deal with the top part. 4 times x is 4x. Minus 4 times x is minus 4x. Minus 4 times h would be minus 4h. Now this part here, and this part what? Rationalize. You have what now? You have the limit as h approaches to 0 of what? Okay, you have the limit h approaches to 0. That was that part there. So now you have 1 over h, that means negative 4 h all over x into x plus h. So now this part here and the top one, rationalize. So now you got rid of that. So now you have the limit as h approaches to 0, negative 4 all over x, and then x plus h. So now we reach the stage where we have to plug 0 where there is h there. So you have 0 plus x is what? Is x, and then x times x is x squared. So therefore, the derivative from first principle here will be negative 4 all over x squared. That's it. Understand? So now this is just negative 4 all over x squared. This one, you can just take the derivative directly, and you're going to have dy with respect to x. It is just 10x plus 5. But for 2 marks, they're going to mark here and there. Not here and there, but yes, they're going to mark you guys for this part and then for that part there. Just 2 marks. So you're done with that one. So this one here, you have dx. I'm just going to write what is correct. So you have 2 all over 3. So it's the opposite of what you're seeing. So it has to be an exponent. And then this one is nice like that. So taking the derivative of this side, you have 2 all over 3x. So 2 over 3 minus 1, that's 3 into 2 minus 3, you have negative 1 all over 3 there. So now this is negative 1 over 3 into a half. Then you have to take this further and see this is 3 into the square root of x, and then 3 minus 1 to that like that. So this one, I think the space will be fine to be 3 here. So this one, guys, listen me very carefully. So now they say that if you are given a pair of x, which is equal to that. Now you have what? You have p of x, which is what? X cubed plus 2x. They say show using the derivative calculation why it is not possible for a tangent drawn through E to have a negative gradient. Guys, there are two possibilities um, for you to show them that indeed it is not possible for a tangent drawn to this function there to have a negative gradient. Number one, you can simply do that by sketching. Number one, you can do, okay, I'm just going to say, number one here, you can do it by what? By sketching. Number two, you can do it, what is this? Okay, number one, you can do it by sketching your gradient, sketching the gradient of this form or this one. Number two, you can do it by sketching the original function p of x. Yeah? So number one, let's deal with the number one sketch. So you take the derivative of this, you'll have what? 3x squared plus 2. Guys, trust me here, you don't have the x-intercept. You then have the y-intercept. Why? When you want to find the x-intercept, you say in the place, or when you want to find the y-intercept, you say in the place of x, replace with what is 0. Yeah? So it means now you have what? When remember, when you take the derivative of this, you'll have something like that. So remember, here, when you want to find the x-intercept, you say what? Let x be 0, right? So when you let x be 0, you have 3 into 0, and then it means now y is what? 2. Yes, this one is possible. So what about the x-intercept? The x-intercept, you let y be 0, right? So it means now this is negative 2 into 3 over x. And then when you divide both sides, you have negative 2 over the x. Can you take the square root of this? No, you don't have what? The x-intercept. So guys, you don't have to worry about going to find it. Once you don't have the x-intercept, don't carry on trying to find the y-intercept. Simply draw a table like this and say, this is what? This is x, this is y. And simply come up with your own values. I'm just going to take negative 2. Let's see what is y when x is negative 2. So let's bring out our calculator. So this is 3 into negative 2 squared, and then plus 2. Y is what? Is 40. Worry about when x is negative 1. You'll have negative 1 there. This will give you 3 plus, that will give you what? Plus 5. You'll have 3 into negative 1. This, since you have an even number there, even exponent, this value will give you what? A positive thing there. You'll have 3 plus 2, that's 5. So it means now when we x is 0, what about y? Y is 2. Then y is what? Y is 2. So now what about when, okay, just going to continue like that and write when x is 2 is positive 1, you'll have a positive 5. When x is positive 2, you'll have what? A positive 14. You can try it there. Put 2, you'll have something like that. So now our sketch will look something like this. Since this is the value of a, it is what? Greater than 0, meaning positive, you'll have a smiling function. So you have negative 2, you have a negative 1, you have 1, you have 2, and then you have a negative 14. Let's say this is negative. Oh, we don't have a negative 14. Sorry, we don't have a negative 14, but we have a positive 14, and then we have a positive 5. Positive. So which one goes with negative 14? Which one goes with negative 2 is 14, and then negative 1 and 5, 0 and 2. And then 1 and what? And 5. And then 2 and what? And 14. So this is what your function now. This is what the p prime x. This is what the p prime x. So now, after having this, guys, how are we going to prove it now? We have to show. Remember, this is relevant calculation, guys. This is what they mean by relevant calculation in math. You show by doing calculation. This is calculation. They're going to mark you, guys. Trust me. So for drawing this, they're going to mark you. Remember, this is now what? When we take the derivative, now this is what? The gradient. It means now this graph that we drew here, it is what? The gradient of what? Of this function. Yeah? It is the gradient of what? This function there. So now, let's plug in whenever we plug in, or okay, whenever we plug in whatever value we plug in at x there, whether it is a negative million, positive million, you saw that the product is what? Is always positive. The product is what? Is always positive. The reason is what? X raised to an exponent of 2. Your 2 is an even number. It doesn't matter the value you replace at x there. It will give you what? A positive product. Yeah? It will give you what? A positive product. And then when you add the 2 there, it always what? Give you a positive product. Let's try it by plugging. I'm not going to try it again, because even if we try by negative 3 there, you're going to have what? A positive value, guys. This 3 raised to that will give you what? Will give you 9. And the 9 times this plus this, guys, you see, it is a positive value. So this tells you that this gradient here, no matter value that you put, it always have what? A positive gradient. Yeah? This tells you now we have what? A positive gradient, guys. This is a positive gradient. I can say m, positive m, positive m. Remember, this x at 2, we are checking what is the gradient at x is equals to negative 2. The gradient is what? Is positive 14. At x is equals to 2, what is the gradient? Positive 14. You see, no matter what value you put there, the gradient will also what? Have a positive gradient. That's number 1. Number 2, let's sketch this function. Also here, you're not going to have what? The y-intercept. Okay, the y-intercept is just 0. What about the y? Y here, you'll have to take out the x and then you have the 2. This is x is equal to 2. What about x squared and minus 2? You are not going to solve that. You see? You don't have the x, you don't have the y. We can also use what? The table there. So using the table, I'm just going to Just plug it here. So let's say x is -2. What is y? To our original function now. So you have 2 into, okay, you have -2 and then cube and then plus 2 into -2. You have what? -12. So now let's say -0 and 1 and then 2. Here, what about when this is -1? You'll have a -1 minus 2. This will give what? A -3, and then 0 at 0, and then 3, 2. So now when we sketch this type of a function, you'll have a -12. What is this? You'll have a 12 here. This is 12, and then you'll have a -3, +3, and then 12. You have 1, you have 2, 1, 2, negative, negative. -2 goes with -12. -1 goes with what? Negative. That 0 is 0. This is 0. That it's not a straight line, guys. Remember, it has to be a cubic function, and they are not drawing to scale. It has to show that, yeah, it is curving like that. So this is P of x. So is it possible for us to have a tangent? Oh, okay. Is it possible for us to have a gradient that is negative? Remember, a gradient that's negative has what? A negative slope that is decreasing like that. A positive gradient, this one is negative gradient. A positive gradient, guys, is the one that always does like that. Always think of your right hand thing like that. That's what a positive gradient. So is the graph is the line that faces where goes like that and faces to the right. It always faces to what? To the right there. That's like it is going up. It is going up, it is hip. It is going up, down, it is not hip. That's a negative gradient. Is it possible for us to come to this gradient, to this function here and say we can have a negative gradient like that? No. Remember, a tangent is a line that touches a curve at exactly where there is a curve, like that. Once you have, let's say, once you have a line that's going to do like that, bisect like that, now their perpendicular is no longer a tangent. So now they're perpendicular. You can see that maybe they are making what? A 90-degree. So now they're not, now that line is no longer a tangent. A tangent is a line that is going to be like this. You can see that this one is what? A positive gradient. This one is a positive gradient. Every point. This one is what? A positive gradient. That it is what? A positive gradient. So you can conclude and say um the function okay, I'm just going to conclude about this one. This one, the second one, this one is the first one, the first option, eh? And then this one is the second option. So you can say now the original or the function p of x, which is equals to x cubed plus 2x, has a positive gradient everywhere. Understand? That's what? A positive gradient everywhere. So it is not possible for us to have what? A negative gradient. And then this one you can say the the gradient of what? You can say the gradient or the function. Okay, you can say the function p prime of x, which is the gradient of what? The original function. Any value that you substitute there, whether it's a negative or a positive, it always produce what? Or always give you what? A positive value, meaning that the gradient is always what? Greater than 0. No matter what value you substitute here, it always gives you what? A positive value, telling you now it is not possible for your original function to have a negative tangent. And then done like that. We don't have another question. So we're just going to end it here. Guys, please don't forget to subscribe. Né? Please don't forget to subscribe. Like, comment, guys. Comment. Even thank you is enough. You don't have to say anything. Thank you is enough, guys. Understand? So please don't forget to subscribe. Don't forget to subscribe. You should help me reach 50 subscribers by the end of this month, guys. Please. And I will see you guys next time when we are busy with cubic function. Yeah, this is the end.